efforts are underway to get Julian and Dave in here by the end of the week. Hopefully we'll get them in here. And I don't know what we'll do. We'll probably continue to work on Dave's synthesizer. This thing sucks. But I think we have a little bit of, I made a little bit of a breakthrough. Not much. It's just like a suspicion of what might actually be wrong with it. Maybe. We'll investigate that today. What's going on around? Motion at the garage. All right. Whew, woke up late today. How's everybody doing? There's nobody here because it's been a couple days. I had two people here. It's me and Gonad. Users in chat. There's more than just Gonad. It just takes a little while for Twitch to propagate it, so it's always fun to look and see. I have 2 viewers. I remember those days. I remember those days. How are the cameras doing? I didn't shut down OBS because it's a major thing for me to start up stream without my automation. The automation is so important. So I started to set up the other room as a 3D printing location for resin specifically, just because nobody's used that room in ages. And if it does get smelly, at least it'll be not in this room. But it's still a lot of work. I gotta do a lot of rearranging of stuff and get things together and possibly have a fume exhaust on the printer itself. There's things you can 3D print to go on the back of the printer. Problem with that, PETG does not get along with resin. So that means moving back to PLA probably for my printer. I have plenty of PLA. It's in a bin in the other room, actually. But I got to get it out and move it in here and figure out what my settings are. I haven't printed PLA in literally like 5 years, so I'll have to figure out how to do that. And then in addition to that, with the resin printer now in the other room, once I get that spooled up, I will be able to print the laser housing for burn the subs. And I'm wondering if I should experiment with adding a little bit of dye to the resin. Problem is I only have 1 bottle of resin and I have no bottles to store the resin. So what's up, Carvos? So if I tint that like blue, then I permanently have a little bit of resin that is tinted blue and I don't know what to do with it. Can't put it in a clear bottle. So I got some figuring out to do. Not too much. That took me a minute to decode for some reason. Doing good today. How are you? I'm doing okay. I've been sleeping a little bit better. Baby steps. I'm going to get there and get to actually sleeping like a normal person. I haven't eaten lunch, but I'm not hungry. So I got to start doing that more. Not eating lunch. Get those calories down. Because last week, the end of the weekend was like calorie city. And I kind of overate. And I don't want to feel like that anymore. I don't like that. But I've been working on this stuff and moving things around in the other room in order to sort of redefine one of the spaces in this house so that I may have a little bit of spillover room because, I mean, you know, enough is enough. I've got too much stuff and it's choking this area. It's just choking everything. Burn the subs, of course, we need to go back and do more hardware on. In the meantime, I have been trying to figure out how to get Mosquito running. Can I run like a non-Raspberry Pi Raspbian install? Can I just install Raspbian in like its own little virtual machine? Because that would be a fun way to do it. Because I know how to do Mosquito on Raspbian. I don't know really, I'm not familiar with Ubuntu. Rest and moderation. Yeah, sleep is apparently a big thing about weight. That and drinking, which is something that I'm trying to reduce. Something that I need to reduce. I get bored. I need to stop myself from getting bored and looking at the bottle for entertainment. Stupid. Got my sleep back to normal. It took weeks. Yeah, it's tough. It takes 3 weeks to build a habit. So 3 weeks to build a habit. That's how I got into exercise. When we first moved into this place, I had people coming in and out constantly. There was construction because it's a 1990s house, so like everything sucks in here. So we had to have a lot of stuff like redone. Old soap gun? I don't know what the hell that... Old soap gum. Is that a weight loss? That's ridiculous. I know nothing about that. I know they used to sell tapeworms for weight loss. That's ridiculous too. No, I used to go to the gym every day at 4 o'clock in the morning. I mean, I would wake up at 4, take a shower so that I remind myself that I'm human, and then I would go to the gym and meet a buddy there. And that was because we had construction people coming in and out of the house, so I had to be awake for their hours, and they came. Sometimes they would come early, so I had to like get myself into that and motivate myself to do that. But 3 weeks to build a habit, and then it dropped off suddenly, so that was bad. That was bad. I needed to keep up that habit. Thrills gum has the taste of soap. It's probably the only product that is still made 30 years later. Is it just like cilantro gum? Is that what it is? You can tell by the the blast radius here that I have been hard at work. I took the circuit that we built last week and I moved it on to 2 breadboards instead of 1. So I just like transferred parts over and sort of reinvented a lot of the stuff on there and spread out more so that I was able to access everything and that our circuit wasn't super crowded. So we've got all the components here of a diode ladder filter done with PNP transistors, but none of the transistors match. I didn't match pairs. So it's possible that today we should go through and match pairs to try to get the functionality out of this. I'll explain more later, but this has been the sort of culmination of quite a bit of work that I've put into this. This is Sasha and Digweed Northern Exposure. This is an early 2000s mix, and it's great. I loves it. It was the music that I used to listen to. Oh yeah, let me get all my chats set up. Sorry, YouTube, I have not set you up yet. I just remembered. All of my automations are broken. I'm one of the 1% that doesn't taste soap and cilantro. I can almost see where the soap tasters are coming from, but I also do not taste soap and cilantro. Let's pop out that chat. Hey, Madam U, how's it going? All right, there you go. You're on screen now. Did that just say Beef Wellington? And there's my social stream blade. There we go. Perfect. Yeah, I've been buried in circuits. Actually, I found out that using these stools in order to build the circuits, not as good. I took my office chair over and because this is about at this height when I'm in my office chair. And so my head was right up against this circuit and I was able to build things a lot more easily because it was right up in my face. Apparently that's a good strategy for building breadboard circuits, is to, throw them up against your face. Who knew? All right, let's see. What is my hair doing today? It's doing weird stuff today. I can't really control it. Once it locks into a position, that's it. We're done here. That's just gonna be my hair for the rest of the stream. Oh man, this is so many circuits. I'm looking through some of these notes here. It's so many different circuits. It's so many different elements in order to get all this stuff together. And then this is just baffling, the way that it's presented. This would be the thing that's, this right here on the 2.2K right here is pulling current down. And so what's going on here? It's like you've got a bias sitting in here. Why does that exist? And then over here, what is this part? That's a trim. So envelope and decay, which decay would discharge this line, which is triggering that. But then where does that come from? That's an envelope there, and that's coming from cutoff frequency. So it's like a feedback. So this goes out to the cutoff frequency. Then why is this going on the, like, Darlington practically array? It's so confusing. I guess but that's resonance feedback is different, but then that goes out to resonance feedback, but it also goes back and around. Oh my God, it's so confusing. This part of the circuit is just straight up baffling, and you can pull stuff out of it and try to kind of get to know it a little better. I think a rearranging of the circuit structure would be good if I did this in my notes to understand exactly what's going on, but there's a different version of it, which is the Hajiwo circuit, which is this one over here, and Haji was using diodes, but he has a much simpler current control that doesn't do the same stuff as the Moog one does. It doesn't have like envelope and stuff like that. Instead, we're just using an op amp in order to mix it up between a knob and a CV, and then we reduce that to the point where it will trigger this transistor, and these two will fight for the total amount of current that can go through 4.7K. So these two fight this 4.7K. I guess 4.7 up to 12 volts is equivalent of 12 volts and 1K, then through the rest of this stuff. So 1, 2, 3, 4, 5, 6. 0.7 by 0.6 is 35, is that right? 7 and 7 is 14, 28, plus 14, 30, yeah, 35. So 35, is that divided by 2? I'd have to do more current calculations to figure this out. Versus 4.7K. 4.7, 4.7 is half of that. And then this one's 35, sorry, 3.5 volts. I don't know. I'm not doing all that math right now, but I wonder how the loop calculations come out. Oh yeah, the Alanis Morissette song. So I can have multiple copyright entities come in and try to claim this. This is Sasha and Digweed, Northern Exposure, CD1. I used to listen to this a lot in the car on the way to raves. And then, from the Discord, I have a site that I found where they took the circuit and they put it into this little simulator. Synthesizer build, part 39, Moog ladder. The Moog ladder filter. This is going to make my computer heat up. Well, this is apparently a current simulator of a square wave going into the Moog ladder filter. So as we enable current to come down through this transistor, we enable more frequencies to get through the ladder, because these are like variable resistors or something like that. They're like current-controlled resistors. And so the more stuff gets through your ladder, the better, I guess. I don't know. In this case, we have this resistor ladder here that is giving different voltages to the bases of these transistors. And so that's what's causing sort of the, I guess, the ladder effect to happen. I guess you can also just loop the transistors and use them like diodes, which is what Moog does and what Acid Labs does. That's kind of hard to see what's going on here unless I up the speed. Now you can see more current flowing through stuff. I guess that 150 is there just to bleed out excess. Why would there be a 150? Oh, and then it joins up. I see. Okay. Of course, the 10 UF, or sorry, 6.8 UF capacitor right here, that can be considered like a balloon. Like not like a storing, it can be considered like a membrane between two water bodies. So the push-pull is happening on the other side of that balloon and affecting this current level. We have an adjustment over there too for, I guess, the resonance. That's just called T3 trimmer. Any crew? Negative. But then I guess this would be the cutoff. That's coming from here. So it's bleeding out this line, which goes to the input voltage level. So then it splits between the resistor ladder and the cutoff all the way down to here. But cutoff is also supplying this transistor. So you're biasing between whatever's left after having the initial voltage level in cutoff, and then you send that to the base, which is allowing current to flow through and sets that current level. What the heck? But then what is the cutoff adjustment doing? Because this is going to be a fixed value, but it's going to be split between these two. So it's split between these two, so you're sending the excess over to some kind of a reduction and a hold off. So, but that, wouldn't that, this is very confusing. I'm thinking about loops right now is my problem. This one point, wait, that's connected there? That's different. That's totally different. The designs, wait a minute, what about the other designs? Not connected. Unless it's a typo, but that's not connected there. Nor is, yeah, that's still in close little circuit there. What about in the Hajiwo design? Hajiwo. Yeah, it's definitely, okay, he does the whole circuit jump thing, so it's definitely not connected. This is its own little ecosystem, apart from the 2.2Ks that are coming off of the bases. And then he has a voltage divider on the 12 volt to ground. So that would be a 6 volt bias on there, bled off by, well, that's a 10 off, so that would be defeating any DC. 2.2K, and then these coming up there, and they both have isolation on them. I don't know. Hey, what's up? Niano Cat? I was going to say Niano Cat. How's it going? I'm trying to think about how these diode ladders work, and it's very complicated. But I did find a really good simulation, although it seems like it's not quite the circuit that we're hoping for. Oh, I was in the wrong place. Oh, I see. I was in the wrong place. This is the differential amplifier that's creating the output. So the differential's created over here on the two transistors, on the two sides of the capacitor, rather. So that's being biased back and forth. Current going through there, going through there, going through there, and each time it has a voltage drop-off, but its reactance is what's important because it's letting certain frequencies through and not letting others by the time you get to the end of the ladder. Complicated. I don't totally understand it. Okay, so that does jump over. Those are not connected to each other. Mostly it's the frequency control here that we're worried about. And we'll get to that when we get started. I don't know how this stuff works, but I'm learning. I'm learning. We're getting there. Slowly. Slowly but surely. I think I am going to not put the resin 3D printer in the big casing that I used to have. Like, I've got the Creality print, like, tent, and that can almost fit my FDM printer, almost, if I stretch it a little bit in certain places. But I think I'm not going to use it for any of the printers right now. Maybe I'll use it as a grow tent in the future for my peppers that didn't grow this year for some reason. I don't know why. They just didn't grow. I don't understand. Not a single one grew. What did I do? But anyway, I think I drowned them is what happened. I'll have to experiment with like ways to get the seeds to germinate next year. But yeah, that tent has no other use at the moment. I use it as a fume tent, but in the mornings I would come down here when the fan wasn't on overnight, and I would still be able to smell just a little bit of resin lingering. So I'd turn on the fan, it would go away. I think in order to contain the mess, I need to have silicone rubber mats all around the printer because it is just a mess creator. Everything can be done very cleanly with a resin print, right up until it doesn't. Resin printing, it makes a lot of sense, right? You expose an image, you harden some material, some epoxy material, pull that away, put the epoxy material back on, expose the next layer. You can have hilariously small layers that go together to create a cromulent piece of plastic, a big solid piece of plastic. It's a cool technology, it works. But the resin is nasty. It can be nasty, it can be not nasty. I mean, it's the UV resin that you put on your nails. People are like, it causes cancer like immediately. It's okay, I've gotten it in my mouth. But does smell a little bit, and it's best not to just constantly expose yourself to it. Now, when you clean the resin printer, when you pack away the resin and put everything back together and put the hood on the whole thing, it doesn't smell. Like, moving the resin printer out, I haven't been exposed to any of the smell. I don't smell it at all. So having it in like a room is fine. People make resin printing closets in order to contain all that stuff. I do have an exhaust fan that I could use, and I would like to print out something that would exhaust the resin printer without the whole hood around it, because I spent the money. I spent $30 on that filter. I want to actually use it. But yeah, I think what I need to do is print out, you know, get PLA on my FDM printer, PLA on the Creality over there, and print out one of these adapters, the sort of suction adapters, and then when I run the printer, I'll run that filter, but it'll also be in the other room where there's more air space. I still, like, my dog sleeps in that room, so I don't want her to be exposed. Well, she sleeps sort of to the side of that room. She sleeps by the stairwell, but I don't want to expose my dog to those fumes. She'll be fine, but I think with more room to operate, and then having more room to operate, having it on a tabletop where I can stand and it's right in front of me, means that I can maneuver things without getting it all over the place. Because before I was crouching down, and crouching down, you're like, well, okay, I got to reach under and around this thing, and it doesn't work out. So ESP8266, cheap capacitance moisture sensors. The problem with that is those capacitance moisture sensors go bad. There's an electrolysis element to them, so you need to replace them. So like 10 years ago, 5 years ago, I wanted to set up a bunch of moisture sensors for like the garden and stuff. It turns out they just go bad. They're a wear and tear item. What I would love to do, I found on Thingiverse, I found a bunch of drip watering supplies. So if I get a ton of the hose, I would love to set up on a solenoid a drip watering system for the alleyway. And I think that's maybe a winter project. We may look into that during the winter, because if I could just have a hose splitter and have a solenoid, then I can have Node Red manage watering depending on moisture, like depending on atmospheric readings that aren't even local. Like I can get an atmospheric reading from nearby and have that sort of dictate, oh, the soil's going to be dry. So that kind of stuff. I think that would be really cool. Like light cycles and stuff like that. Not like Tron light cycles, I mean the cycle of light on the Earth. That's a cool one, but again, these projects are totally extra to what I should be doing, which is trying to actually make money and burn the subs. And you see, this is ever looming over my head until I can get this fucking thing started again, and then I can breathe a sigh of relief and actually do some of these projects that kind of come to us naturally. Coming up with the idea for a project is easy. Saying no to a project is tough. Telling other people no because making up projects is easy is also equally ridiculously tough, because people don't know that the easiest part about doing projects is coming up with an idea. The execution of the idea requires tons of experience and knowledge, and you got to tell them, you got to do your own project. Just do it. Jump into it. And they'll be like, no, but you have the stuff in it. It's like, dude, I did the work. Like, that's the hard part about doing project. I think the Alanis Morissette was the end of CD1, wasn't it? Oh no, it's still going. We're still going. We still have CD left. I'm getting cramps from yesterday because I was moving furniture around and moving furniture around solo. So every now and then I'll move my back a little bit, and my diabetic body is like, lactic acid, and I'm like, and I have to like move my back in another way until it calms down. Ooh, I used to get this one swimming. Cheat. Add a Sharpie to the head and a Post-it note saying Lazor. That's not even remotely. That will not accomplish anything. I don't have every other component to burn the subs. Right now, burn the subs is configured in the old way, which is to log into the Twitch API, which is long since expired. Its credentials are done, but it will not know how to do its job anymore. So we need to go in there and just kind of pull the wires a little bit and do that. I do consulting work. I do consulting work as well. I haven't had a project in a little bit, but I think I have some stuff coming up the line. And a lot of the stuff that I consult with, I can't stream. I can't stream it. There's a little bit of product development in there, and a lot of CAD work involved. Missing component, post-it note. We will get, when we get to this testing stage of hardware burn the subs, I will put stuff up on the board that we can burn through. It'll make a horrible smell, but actually, what happened to my brown packing tape? I don't think I have that tape anymore. I had brown packing tape that I would use. So we'd put up I'd put up painter's tape and then a layer of aluminum duct tape, the shiny stuff, and that dissipates the heat. And then I'd put on top of that brown packaging tape because it's a similar color to the board. And so we'd focus the laser on that and do test runs. I know what I'm doing. I can cook. I can cook. But I've been able to cook because it's been taking so long. Speaking of Twitch API, have you seen anything on how to get working with a RP2040? I've been wanting to make a live sign that shows me if I'm still live, but the last API change killed all the code I can find. What was the last API? I haven't worked with the API for quite some time now, and I guess that's probably the sticking point. Because we had ESP8266s, which, similar to the RP2040, you can run the same code. We had ESP8266s in Arduino language running the Twitch API and logging into it and doing everything. The Fartbox has since expired, though, so we're trying to revamp that whole system to use Node-RED instead. So I'm coming from a different perspective at this point, and I'm not up to date. So if you're having troubles with an API change, I can't help you. I don't know. I don't know. The Twitch subs API is annoying because even with channel points, they give you a unique alphanumeric transaction ID. You get this code, and I could store that in a database and say, this transaction has occurred, and we've done something with it. And so if it comes up again, if it gets resent by the API, I would know not to do anything with that. Problem is, that's channel points, and channel points generally just do silly shit, right? Some streamers have had them do more intense stuff with channel points, but channel points generally just do stupid shit, like blow bubbles or something, all right? It's not that big of a deal, except maybe the one that makes you take a shot for channel points. But either way, having that system in there, it's nice, it's over the top. What's not over the top is putting that same system in use with subs, because subs represent a financial transaction, and I'm interested in money changing hands. If money changes hands, then we do something intense. We do something really cool. And I stop everything and I do that. But they don't have that in the API. Maybe they do now. Maybe I'm wrong. But they don't have that in the API. So I had to make a whole gauntlet of conditionals that a name would, like a sub event would have to go through and check off before we allowed them to the next stage. So there was a whole thing about, like, have they subbed within the past less than a month? Have they done this? Have they done that? Blah, blah, blah. We had to come up with these on the fly because people were able to sub 3 times off of repeat announcements. So, I've never had this happen before, but I don't know. People were red hat testing the board because it was one of the best things you can do is break the board, because then we get to fix it and it's stronger as a result, right? It's more secure as a result. The guy who went right to something or other porn after the stream needs that sign. The vintage on-air signs. My brother used to have one. I need to ask him about it. I need to ask him if he still has that in his keepsakes, because I would love to put it outside the door here and have it actually respond to Node-RED seeing that I'm live. You see, with Node-RED and a Twitch, even an OBS monitor, with an OBS monitor in Node-RED, you can just draw a line over to on and off, depending on whether your stream is live or not. That's a thing you can do. And so you can just turn on a light when you're live. So I could have red light when I'm live, blue light when I have OBS open, like that kind of stuff. You can do all kinds of cool stuff. But a vintage on-air sign would be really fun to have. They're like $75 to $100 if you get one of the ones that's like good and not like a shitty replica. There's decent replicas of them. And by the way, they were never good to begin with. I mean, they're really cheaply made. It's just like bent like tin that's been riveted together in order to make the sign. They look nice, but they're tin and glass. It's just they're really expensive now because making things that are vintage is tough. But yeah, I found a website that sells them, and I'm like, I really want to pull the trigger on that. I'm gonna wait until we get other stuff working first, like our Fartbox front end and things like that. I could even put an on-air sign like there over burn the subs. We're listening to some old school oh bother headphone music, probably partially responsible for the reason I hear E at night, is Sasha and Digweed's Northern Exposure album. I have trouble with coming up with what we're going to listen to at the beginning of the stream, because I do like things to be a little bit more poppy and kind of get me in the mood and wake me up and get me nimble and ready to be on stage, because I mean, why isn't that working? Oh boy, what is going on, computer? Hello, computer? I don't remember the talking parts of this. I think I have to close this because that's taking up a lot of computer resources. There's a big slowdown when I went over to that webpage. But yeah, I need to be like punchy for stream, because although introverted, I need to be an extrovert on Twitch, of course. So hey, what's up, Brink GG? How you doing? I haven't looked at Mosquito yet. I was actually asking at the very beginning, when there were like 2 people here, if can I run Raspberry in like a virtual machine? Can I just do that? Can I just run like a Raspberry Pi clone operating system on my server somewhere? There might be an app that does that, actually. Because if I can do that, I know exactly how to install Raspberry, and I know, or not Raspberry, I know exactly how to install Mosquito and all that stuff. I don't know, just a thought. Mosquito should be its own thing in the App Store, but that App Store sucks. It's not good. And I can also make my own containers in it, too. I can do that. That's probably the way to go. It's just once I make my own container, like, what do I need like an OS and stuff. Unless that's tied to the NAS OS, in which case, it's so complicated, Linux. Why do you gotta make stuff so shit? I guess TrueNAS did that. Oh well. Yeah, we got some stuff to get through here. This is somebody else's synth build, but they made a really helpful visualization. Structured for ARM processors. You'd have to emulate the ARM process off an x86. What's AMD? It's an AMD machine. That's on ARM? I don't think that's ARM. I don't know nothing about nothing. AMD only makes x86. So I already have x86. So could I just run Raspbian? I should learn how to use this in order to make our specific ladder filter so I can see what's going on. Google says you can. So I could just open a virtual machine and throw Raspbian in there and then do the tutorial on Mosquito. And then I could get into it with WinSCP. There's a tutorial for it. Nice. Okay. I'll have to think about that. This bugs me. That should be like that. Oh no, I ruined it. I guess I shouldn't touch anything. What are you doing? Ain't doing nothing. So what if I take the trimmer and I actually make some flow here? Or rather, cut off flow? Yeah, make that as big of a resistance as possible. And then cut off. Now I've actually got a little bit of circuit flow here, and a lot less through here. For some reason, this is supplying. Nothing big happened over here, though. Oh, that's because our input wave is still the same frequency. If I up or lower the resonance, we get this. This is what I'm seeing in the filter that I built on the breadboard. This is like really sensitive too. It's like as soon as I start messing with it, I just ruin it. That's just gain. It's weird, the response that I'm seeing out of the filter that I built is very similar to what we're getting here, because in a very specific scenario, I get the proper sort of, I don't know, top and bottom of the wave doing weird stuff. Let's just reload that just so I get my settings back. Actually, I'm going to close this because it's going to freeze up all my camera equipment. the scene switching gets a little bit squirrely. Tutorial just shows you how to install Debian on a virtual machine with the Raspberry Pi packages. That probably won't work for what he wants to do, as the apps that he's trying to run require ARM architecture. ARM-catexture, if you will. Oh man, I don't... So listen, what I'm trying to do is set up an MQTT broker. I just want to set up Mosquito. Maybe I need like a Lubuntu. Maybe I'll just download Lubuntu and then I'll have that to deploy in a virtual machine. Because at the moment, you can create an app, and maybe that's what I need to do. I don't know. It's audio, so ruin means add character. That's true. Yeah, this module is totally broken, so I use it as a noise source. That is a thing. That is that is very true. So yeah, with the printer in the other room, once I get that all established, I'll be able to use the power of resin printing in order to create the laser diode shroud. And that will get us sort of to the next part of Burn the Subs. I got kind of caught up. I got caught up with Burn the Subs in trying to water seal a laser. And then I discovered you could buy broken resin printers. And so that led to me getting a resin printer just specifically for the purpose of creating that laser diode part. That means that if I need highly detailed parts, though, I can create them. So if I really need to make like labeling for stuff, or I don't even know what I can do yet, because it's not super strong. It's as strong as like cheap plastic. So things aren't exactly as functional from the resin printer as I would like them to be. But you can also get functional resin. You can get strong resin. I don't know if I want to heat cure stuff though. It seems a little weird to me. I'll learn eventually. But yeah, this is just one of my tests of the resolution of the printer, and it's kind of insane. Like, this 3D model is not incredibly detailed. You can see the cod piece right there. Let's look closer at the cod piece. There we go. Tell me about this cod piece. Now, if you look really closely at the cod piece, you can see there's layers. But there's like up here, there's like in the collar and stuff, there's like triangulation kind of structure-y things going on. You can't really see because this isn't one of those gray resins. The gray resins, of course, will show everything. This is clear resin that I just bought on a whim, so. But yeah, if I need super detailed like electronics enclosure parts and stuff like that, this will probably do the job if I keep it thick enough, because this is pretty strong in its thickness. And I got the ultrasonic cleaner for electronic cleaning, but I haven't really used for that. It's sitting by the utility sink in the other part of the basement. But that can also be used to clean up the resin from prints pretty effectively, I might add. I just need a way to use and reuse the alcohol. Oh, what else did I do this weekend? I don't know. There's a lot of stuff going on. I actually met Uwo's lab. To all 4 of my viewers today. That was kind of cool. I bought a bunch of beer. I hadn't been to this place in Ardmore in 4 years, so I went and bought crates of beer, and so now we have 2 more project crates if it comes down to that, if they survived, because it was so humid that all the beer cans were like sweating into the cardboard. I don't know if the cardboard's going to survive. I probably need to move all of that stuff out of the cardboard and then dry off the cardboard. Which would be 2 more project boxes. We need to clean up that corner of the shop. The stuff that's sitting behind the fans and the 3D printer there. All of those bins, I need to go through. I need to go through them because it's been too long since I established that space. The other day, I made a horrible 10 by 1K resistor bank from 1,210, or do you mean 1210 as like a size? Is that like the surface mount size, or is that the number? 10 by 1K. I've seen people dipping UV LEDs in tubes into the alcohol to solidify residual resin for easy filtering. Apparently what you're supposed, I don't know about filtering, but I guess if you sealed the container and you put the alcohol outside and just exposed it to the sun for a little while. Oh, 1210 size, okay. Those are huge. That does sound like a horrible resistor bank. Yeah, most of my time I've been spending in here rearranging stuff. We had a huge storm yesterday, and that cooled out the air, and it's nice now. It feels like springtime suddenly. I think that there's going to be an end to that soon, and we're back to our permanent heat wave. But yeah, it's been breathable for a little bit. So I've been doing a lot of dog walks, short dog walks, but still dog walks. What else have I been up to? It's just been this resistor ladder circuit. I spent a significant amount of time doing what you guys are looking at down here. It's taken quite a bit for me to get this whole circuit down onto a breadboard to the degree where I can actually explain to you guys what's going on. I'm going to slow down this stream, even though I'm pumping myself full of caffeine right now. I'm going to slow down a little bit, and we're going to go through piece by piece, and I have sort of a pet theory of what might actually be going on here that leads us to Dave's synthesizer, and I think it leads us to the couple of transistors that are sitting below the supermatched ones. Now, I think it might be down to getting supermatched transistors in this circuit to get this circuit to work properly. Although the simulation that I see over here, the one that we can click in and totally destroy my computer, had it seems to operate very similarly. So I'm not sure if that's how these work. I have these grow lights, the LED grow lights, and I'm going to use those to solidify any residual. Well, no, sorry, to solidify the models. Anything that I print, I'll put in the ultrasonic cleaner back in the other part of the basement in the sink, and I've got a couple bins that I can like put the print bed on and bring it to the ultrasonic cleaner. The ultrasonic cleaner, I think, is a little bit smaller than my print bed. So I might need to make something that'll hold the print bed in water and then in a bag that has alcohol in it. And I need a way to drain that alcohol into a container without making too much smell. So there's still a lot of stuff for me to work out about my printing process and trying to keep it as chemical free or as low chemical as possible. That's gonna be tough. But once you get it down and you get it so that you're not like dripping fucking resin all over the place, it's actually really good. You can do a lot of really good stuff. Used to super glue them in place, and it dried in a white crusty appearance. It made it so much worse. That's a weird, yeah, you don't want to do that. Super glue, I forget what the condition, there's certain conditions where super glue will make that haze. Like, I guess like high moisture situations. And on certain materials, it'll like make a haze. You can wipe that haze off. You can just wipe it off with a little alcohol if you need to. But I generally don't like to use super glue when I'm doing soldering stuff. The only time I'll do it is when I dead bug or live bug a chip. Glue a chip down to a piece of Captain tape, and that way I'm not gluing it directly to the FR4, and I can pop it off if I mess up. I wonder what it would take to embed LEDs in some of these resin printers, because like, just thinking in the terms of like the little boy in me wants red glowing eyes from this power armor, and like, could you just slice a bunch of this off and do a square chamber that would hold 2 LEDs, 2 coin cell batteries, and then a little red LED that points upwards, and then you'd paint over everything so that it would only glow on the eyes. You need to put like some nice primer down though to block the light. That'd be kind of funny to do. Or you'd have the eyes glow blue, and then you also would have something in the fusion core glow as well. One of the resin printer manufacturers sells a stack of cassettes where the alcohol drains from the top to the bottom one. Cassettes? That's weird. I mean, all you do is you run it through a little mesh filter. Oh, wait, no, that's different. Stack of cassettes for the... I mean, the one way people do it is with a vegetable washer. You have like the plastic container that has an insert, and then you have 2 stages of alcohol that it goes through. But I have an ultrasonic cleaner, so I can just throw it in 1 stage of alcohol and just blast it with ultrasound until it's clean, until all the stuff is dissolved away that hasn't solidified. And then remove it from that and like wash it or something, put it under the sink for a second or two to get the resiny alcohol off of it. And then that residual stuff, all I need to do is get that into a container so that it doesn't stink up the whole place. Because the plastic bag is like holes form in the plastic bag from all the ultrasonic stuff. That or the plastic bags I got are cheap. I'm not sure. This is sort of the circuit that I built. Should make a DIY ultrasonic cleaner. There's certain things that I don't want to DIY. I went through the halls of CVS. I went through my local drugstore, my local CVS, and I looked at some of the kitschy stuff that they had at the top of the shelves. A lot of cheap things that they're trying to sell, and one of them was an ultrasonic cleaner, and it was an ultrasonic jewelry cleaner. It was a little cleaner. It was a little thing like this. And it was $7. And I'm like, how could they do that? How could they do that within $7 for an ultrasonic cleaner, which is kind of a responsibility, because those ultrasonic cleaners, it sounds like a bunch of dentist drills in a tumble dryer. So, how could they just sell this little, it's ultrasonic? Well, it turns out I dedicated half of a stream to it. And I said, we're going to take this thing apart and we're going to see exactly how this thing works. It's incredible that they sell it for this price. This ultrasonic cleaner. We look through the documentation, everything's going well. Okay, well, there's a couple screws that hold the back end on it. So I open it up, and it is literally a universal DC motor with a weight on it, with a weight on the side. It was a vibrator. It was not an ultrasonic cleaner. It was a jewelry shaker. So you'd put your stuff in there with the cleaning solution, and it would just shake it. Not ultrasonic. Ultrasonic shakes it at a much higher frequency, which is incredibly effective at getting grime and dirt and dust and stuff away. It's good at getting the cleaning solution to the stuff and having it penetrate the stuff. But apparently this thing was just a universal DC, like a 12-volt motor that just shakes. Absolutely ridiculous. Saw somebody try to DIY one, and the transducers would rip the mechanism apart. There should be no mechanism. It should just be a tub that you glue a bunch of really, really strong ultrasonic transducers to in some way, shape, or form. That's it. That's all it is. And then it sounds like utter fucking hell when you turn it on. I bought one because it's $120. Save up for a little bit, spend $120, boom. Now you don't have another thing to break. You have, your hobby isn't this device. This device serves your hobby. You gotta pick your battles with that kind of thing. I can build everything from scratch here, but that's not the purpose of this stream. I'm not building everything out of mud here. I need some things that just work. So that's one of them. The mechanism in this industrial kitchen steel containers. Oh, okay, so this big stainless steel. Was it plastic? Because, I mean, a stainless steel container would not really be that prone to ripping apart. I wouldn't trust those plastic containers to have something high frequency against it at all times. Where's my soda? I've been staining my teeth with soda. Debating between the transducers and the steel. I wonder what kind of chemicals they use in order to do that in the real ones. I wonder. Stainless steel is kind of an obnoxious material to get stuff to attach to. If you're soldering, you can solder stainless steel, and I've done it before. I've brazed stainless steel with food safe solder, but you have to use a flux that is like a really nasty set of chemicals in order to open up that stuff to accept a tinning. But that's how I made my stainless steel brewing setup, is with all of the brazing bulkheads. So you get a Sparkies use these panel cutouts. They're like a 2-half panel cutout. They're really clean, and so they make big clean holes. So you make the big clean holes with the electrician's panel, whatever they are, extruding cut things, and then you take this bulkhead, flux, torch until you can put a little bit of the solder on there, and then you braze the two together, and you have to make sure that seals water. But that allowed me to make a fully stainless steel brewing setup. Staining stainless needs hard chemicals, yeah. And we were able to blue stainless steel with the soldering iron when we built that hot knife that didn't work for crap. That thing sucked. I spent all that time machining a little adapter, and it turns out stainless steel does not like to change temperature. It just doesn't like it. So I went and bought a $75 hot knife. For the time in the future, at some point, when I take apart all of my old insulin pumps, I have the Omnipods, which have a pretty powerful microcontroller in them. And I think with a little bit of STM hacking, we might be able to use them. That would be nice. And then I can go through my big collection of old used pods and use the hot knife to take all the plastic off of it, get the batteries out of there and everything. And I'll probably need to do like a battery disposal on them. And then desolder all those microcontrollers and maybe make a bunch of microcontroller platforms out of them. It would be pretty funny to sell. That assumes we can run code on it at all, because we don't know the architecture. I would assume that it's very close to another STM product with a couple little add-ons to it to make it run an insulin pump. Like, it needs to have a couple Darlington outputs in order to run the memory wire that advances the gearing to inject insulin. So that could be a fun stream. Oh man, nobody's here. Cheap viewers. Wow. Amazing. How do I block this person? Why is my moderation stuff not coming up on this? I should follow them. Warn them? I don't want to warn them. I want to ban them. Maybe somebody else can figure that out. Automod caught a viewer bot. It would have been more cost-effective to add a Game Boy speaker to it and make a buzzing noise. I mean, like, the vibrating ultrasonic cleaner, it was, I think, as cheap as you could get it, because like those universal DC motors are in everything, like all kinds of toys and stuff like that, right? So you can get them by the bushel with a weight already on them for vibrating. It's like a controller thing, right? And it was like barely soldered to a switch that barely had a jack on it that you could plug in and turn the thing on, and it would just hum. And I guess that gets you far enough. It's just that all the literature on it said ultrasonic, which was a lie. That's a complete fabrication. So I don't know how they got away with it, but people get away with a lot. That was a great stream. And it turns out I did that stream so long ago that it didn't end up getting uploaded, which is very disappointed. Let me look that up. Hey Gear washing station. There it is. So it's a bespoke thing. It has a tumbling platform or something. $400? Yeah, no thanks. One-stop production platform. Efficient, vibration-based, deep cleaning. Use better final results. Look, $120 for an ultrasonic cleaner, and it does everything this does and more. And I have to find a bin that fits inside of the whatever it is, but this is a little bit much. Yeah, yeah. My only problem with the ultrasonic cleaner is that the bed and the bed for the resin printer and the size of the ultrasonic cleaner is a little bit off. I could probably make something to hang the plate maybe, and then that will hopefully not be subject to all the ultrasound. And I don't know. I gotta think of it, because that plate is magnetic, so I could use neodymium magnets in a 3D print and hold them there. That can be PET. No, it can't be PETG. It can't. No, it can be PETG, because that won't be exposed to the alcohol. The alcohol will still be in a bag. So if I put a plastic bag around the print plate, and then I stick it to something, and that something can then hang on the ultrasonic cleaner, because the basket is not quite the right size. For that amount, how much on-screen cleaning can we get out of OBother? Not a lot, because it's in another part of the house that I can't get the cameras to. These cameras are USB, they only go so far, unless I do something with the cell phone, in which case you guys are going to inevitably watch me go to the bathroom, and I'm not willing to risk that. So the other part of the basement is where that ultrasonic cleaner is, because it sucks. It's terrible. It's so loud. It's so loud and obnoxious that it needs to be in another room. It's just one of those things. And I'm not even comfortable putting it with the 3D printer, because it's so loud, and if my dog is in that room, I don't want my dog to be in the same room as that ultrasonic cleaner. That goes in the unfinished part of the basement next to the disgusting utility sink, where nobody has to listen to it do its job. It does a really good job, but it will do a good job somewhere else. And I wish I had control of, like, if I had like a guest room or a closet that I could put everything in, I would do that. There's actually a closet right by the bathroom that I would love to make into a 3D printer closet, but yeah, I wouldn't use coat hangers. I could just print PETG and make a little gantry that I can snap to the build plate and just put it in, just dunk it into the water, the distilled water. Well, actually sink water, because it's what I'm doing is that you fill the cleaner with sink water, but then the alcohol is in a plastic bag with the 3D print. So it shakes off all the stuff. All that alcohol is able to get in and clean out all the resin, and then you pour that into a container and seal it, throw out the plastic bag, and then your part's ready to be cured, right? And you don't have to fill the whole thing with alcohol and have that much like isopropyl sitting around. Oh. Bonk. Oh, this is Last Train to Lasha. I've played this before. Last Train to Lasha. It's a Future Sound of London song, I think. It's so good. I played this just on its own as a track for stream, but this is a Sasha and Digweed Northern Exposure. I'm kind of pulling this one out of a hat because it's early 2000s trance. The polar opposite of a $400 washing station. You don't need, no, listen. The polar opposite of the $400 washing station is a pickle jar, or one of these, it's not really, is it pickle? It might be a pickle jar. One of these British pickly things, and I'm sure we have equivalents of this in America, but you basically have like a plastic container that has a little like sifting thing in the middle of it. You can pick it out of that. So what people do is they drop the print down into that, and then they just shake it a bunch, and then they get their part out and they put it in another one. So you have two of them. And so you do like, one of them is the heavy wash and one of them is the light wash, and then you're done. Like it's very simple. You don't need hundreds of dollars of stuff to run resin printers professionally. I just happen to have the ultrasonic cleaner because if I ever run into a production environment issue, I've got an oven, I've got an ultrasonic parts cleaner. So if I am building boards to sell, if I ever come up with that idea, which I haven't, I don't seem to be full of those ideas. If I ever come up with that idea of a thing that I would manufacture, I could do a stream where we do manufacturing, and I do all, manual pick and place on a bunch of boards, throw them in the oven, solder them, bring them back to the ultrasonic cleaner, clean them off, package them, and then, that's the whole stream. That kind of work is actually kind of fun. I've done that in a couple instances, and it's fun because you have one task ahead of you, right? You're like, all right, I got to do this like factory thing. It's not good as like a permanent job, but it's good every now and then to do something like that. I don't know, it tickles my ADHD brain, but I haven't come up with any ideas like that. I don't have anything that I could like really want to sell and sort of like be behind, like, hey, I'm going to sell this thing and I'm totally going to support it with 100% of my, I'm totally behind this idea. I haven't come up with anything like that. Even the fart box, we took a dollar store fart box. That's not originally my design. Portable burn the subs. It doesn't work. It just doesn't know. None of this stuff. Sell boops on the nose. I don't need to build a ton of circuit boards in order to sell boops on the nose. That's totally different. It's funny, I'm just thinking about this. Somebody commented on these being metal and shorting out circuit boards. I should probably be careful about that. I have silicon rubber that I could put on these. I can't even put channel points behind petting Willow. Because Willow, as soon as I start talking to the furniture, Willow's out of here. She's just like, you're a crazy person, and I'm not dealing with you. On days when I'm not streaming, she will sleep under the desk. So she will sleep in her little den that I have under my desk over here. Those are all the Buldak noodles, by the way. But yeah, I have that little bed and her little blanket right there. And then there's all this crap on the speaker, on the subwoofer. There's all this crap that's built up on it because I put my feet up on there. And like watch stuff on the computer and try to read that book about troubleshooting analog electronics. But like she hides out under there, and that's her little space. I should try Buldak, but they're so expensive. They're very spicy. They're tasty. The noodles are normal. They're not special. I don't know. Yeah, cheaper ramen is probably better. I had to. There was a big like variety pack for like $30, so I did the big variety pack so that I know what they are. Because I'm a streamer and people ask, people want me to know these things. The Buldak noodles are so popular. I also discovered that on those mukbangs where they have nothing but Buldak noodles, that has to be over 1,000 carbohydrates. I don't know how these people do that. One of those things of noodles is like 50 carbohydrates, and that is a whole damn meal, but it doesn't fill you up like a whole damn meal. So if you have leftover like chicken, chop that up and put that in there with that, because otherwise you're not going to get a substantial meal. And it's not going to stick with you. It's just going to go straight through your body, which I discovered about their spice packet. The spice packet's okay. It's right at the limit of my spiciness level. Everybody has a different spiciness level. That level where flavor turns into pain and you just don't taste anything. The Buldak noodles are right at that level, if not just a little bit above it for me. So I'm not getting a lot of flavor out of them. But there were some pretty good ones, and I'm still going through the variety pack, right? I don't think it's going to make much of a difference, though. You could add pyrotechnics to burn the subs. Do you guys think about what you say before you say it? Do you ever just kind of consider and vet out the ideas in your brain? Because your brain probably would like you to work with it a little bit before coming up with these ideas. A substantial donation would burn the sub. Listen, I have a resin printer in the other room. I have plenty of chemicals around here. I do not need to add fire to anything. Plus, burn the subs is already burnt. It already burns. It already burns. I know, it's entertainment. I know. I have to risk it for the biscuit. Like, I asked Uo's lab, like, how are you still alive from all the stuff that he does? Like, I used to do stuff like that, but I don't have the resources anymore, and I've got so much technology. I bought for $1 when I bought my 3D printer, I had a Tesla coil, right? Tesla coil, really cool. Wow, look at the electricity. It makes a noise. And there's, whoa, cool. You could hold a fluorescent light up to it and it lights up. My desk lights are LED and they use a touch panel. My phone uses touch panel capacitance in order to control my insulin pump, which is attached to my body. So when you see these dudes that are grounding themselves and getting sparks shot to their fingers and they're running Tesla coils and stuff like that, they're not surrounded by that kind of technology. I'm in a room full of computers with computers running my external organs that don't run internally because they're pieces of shit. So I had this miniature Tesla coil and we hooked it up to electronic music. I played Sandstorm or something on it and it went da-da-da-da-da, 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 and then my lights turned off. And I went, oh no, because it created so much EMF that it got to the controls for my lights. So no, I will not be doing risky, high voltage, high sparking shit on my stream. I like making stuff with LEDs. I like building things that are weird and kitschy. I like exploring electronics and teaching you guys about stuff I know. I love making explosions and stuff, but I am never going to do that. And also because shows like Electro Boom knows what he's doing. He's an extremely smart guy, totally deserves every single ounce of his fame. But the explosions on Electro Boom are, from my perspective, extremely forced. I can tell what he's doing. You can tell he's doing this intentionally. Some people go, ha ha ha, what a buffoon. It's like, no, he's doing it very, very carefully. And that is fake. It looks fake to me, and I don't like it, so I don't do it. More power to him, though, because it's a very entertaining show, and he's made himself very famous off of that. And I could do that, too. I could blow stuff up. That capacitor that blew up, accidentally, got 70,000 views on the clip, which was a while back, too. So there were less people around. Anyway, we should get started. I don't mean to like be a downer on this. This one's an upper. We're gonna have fun here. Let's get start soon out of here. How do I do that? There it is. Yeah, I'm just setting it straight. Like, I'm not gonna do risky stuff on my show. I would like to continue to do this stuff. I occasionally burn my fingers, and that's probably as far as you're gonna see me force that. Just sparks and electricity and stuff like that. That's dangerous around technology, around computers. So I'm not the kind of show that's going to light things on fire and blow things up. I love that stuff, but I'm not going to do it. Do appreciate streaming not electrocuting themselves, unlike Zach Friedman. I've heard the name. I don't know if I've seen any videos lately. And there's also some of these like backyard experiment streams are doing stuff, or not streams, YouTube videos are doing some genuinely very dangerous stuff. And I am surprised we have not had a mortal, or if not permanent injury on some of these channels. But anyway, that's aside the point. That's not even what we're talking about today. Chat is just, for some reason, pushing their own agenda, and it makes me have to, do these rants about the philosophy of my own show. Boy, howdy, it doesn't get me a lot of viewers, but I would like to remain in the same sort of general shape as when I started the stream. Anyway, hi. This light is on because I lost my automation. I'm going to work to get that back at some point. I am currently cleaning out parts of the shop in order to get Julian and Dave here. And you guys might not know Julian and Dave. Julian does Zelikovich music. So if I do the command, well, you guys can do the Julian command if you want. It'll come up with something stupid. But I want to get him in here to do modular synthesizer stuff. He and Dave are big modular synthesizer fans, and I wasn't until I discovered that you could buy the circuit boards that make up modular synthesizers, and the philosophy behind it is that the creator of this synthesizer is completely burnt out. Do not contact them. Good luck building this, asshole. Here's a tutorial somewhere. So you can find tutorials to build these synthesizer modules, but you're not going to get a lot of external help. Perfect for me. I'm looking to learn analog electronics without having my hand held. I know, I've been doing this stuff since I was like 13, 14, picked up one of those Radio Shack books and read up about it because my brother and I used to build all kinds of weird electrical shit out of stuff in the basement. We would just put like stuff together. We put skis on his RC car for that 1992 snowstorm, the huge ice and snowstorm that we got in the Northeast, and we had like, deep snow. And so we took his RC truck and we put, not Capsella, it was the other one, the one with the four-way snaps that go together, and it had big sets of skis. So we put it all together, and on the steering wheels, the steering wheel hookups, and so we had a little like skate thing that we could drive around in the backyard. That kind of stuff like brings me back to being a 10-year-old. It's amazing. And so I got into electronics at a very early age. I've been working with them ever since. Digital stuff has made a boom in the past 20 years, almost 30 years. The basic stamp led into some other stuff that led into the Arduino. And the Arduino came out, and everything became so easy to do. You could do some really, really complicated projects because all of that complication could be handled in something that you would program. So you could do things with much better technology, and the projects got really cool. And art, people on an artist's level of technology education were able to do things at a much higher level of like sophistication, like big LED displays, and mix that with their art and stuff like that. Just amazing, just absolutely amazing boom in sort of projects and technology and stuff. So I am sitting at the top of that and going, well, it's time to look at analog electronics and synthesizers. I haven't done anything with analog in a long time. The most that I've gotten is a little bit of circuit analysis on something that's very simplistic. A little bit of RF, because RF kind of boils into analog very quickly. RF is very digital nowadays too, but You know, you get exposure to that kind of stuff eventually. And aside from like college courses where you had to do a bunch of equations, and then when you're done, you're like, what the hell was that? And somebody was like, oh, it was AM radio. And you're like, what? That's what those equations were doing? I was just concerned about studying. So that, and that actually happened to me with one of the most simple circuit structures, a voltage divider. I got through college, and I was almost getting out of college, and I had a co-op job at an audio engineering company. And this friend of mine, who was also, I guess, a co-op at the time, mentioned a voltage divider, and I was like, what's a voltage divider? I didn't know what a voltage divider was. And we had the Circuits 101 course where we would do, you know, 2 resistors in a voltage divider, but nobody ever called it that, or it didn't lodge in my memory as that. I knew what it was, but I never heard it called a voltage divider, which is kind of a weird thing. So like that stuff can happen too. But anyway, so like my education was a blur, and I'm getting into this modular synthesizer. It's all analog electronics. I'm starting to learn how to go through and troubleshoot and really get to the bottom of what goes wrong in analog electronics, because I didn't expect it to be as difficult. Some of these VCO designs are fairly difficult to get through. I built a VCO and turned it on and nothing happened, right? And okay, why is nothing happening? You got to tweak and tune every single facet of the design. It's very difficult stuff. So in that vein, we have been working on Dave's VCO. Dave's VCO is an Acid Labs, acidlabs.de, M303. The 303, the TB303 in particular, is sort of the darling of Acid House. It is that tweaky sort of blade-sounding synthesizer that everybody loved using for that era. And the M303 brings it into a modular synthesizer. The TB303 is its own little contained like sequencery kind of thing. I don't know. TB303 is its own little thing. And so in order to make it into a module that takes control voltages in and puts out all kinds of stuff, Acid Labs did a little bit of a redesign to the schematic. They also found parts that were currently available. Supermatched transistors are harder to come by nowadays because we're doing things differently. We've got better technology to do stuff like that. But these old systems, you want to get that signature sound, which often means doing stuff badly. And you don't necessarily do stuff to the apex of technology. You might want something to sound a little bit dirty and a little bit squelchy. So you do stuff sort of in the old ways. So that was part of figuring out what was going on with this board. They scratched off the component names because that was their sort of claim to fame. They figured out how to make something sound just like a 303, and so they didn't want you to have that special sauce. But we are reverse engineers, if anything else, and we're also extremely adamant about stuff. That's sort of the main thing about reverse engineers. You need to be incredibly stubborn. And I am the type of person, in order to identify a device in one of my old jobs, I would go through multiple pages of Google images searches to the point where I got to page 20 and 30 and found what I was looking for. That was the old days of Google. Nowadays, Google sucks. I'm talking about like 2008, 2009. I would be going through multiple pages of Google in order to find the shape of a happy bear device that I had sitting on my desk. You know, obviously it always turns back to Alibaba, but I was able to actually identify what the device originally was on multiple different occasions. That's the sort of like, you know, you get the bone, you don't let it go. You got to be totally stubborn when it comes to reverse engineering, because there's a lot of work. You have to be stubborn enough to want to do all that work in order to figure out exactly what the circuit structure is. I have been avoiding doing a complete and utter full reverse engineer of this board. Instead, I have opted to go and learn a little bit more about the TB303, the Moog TB303. Sorry, Roland TB303. And I've been learning a lot. I do not have as much chops reverse engineering analog electronics, and so I've been reading up about that as well. So all of that together, I had the break over the weekend, and I spent some of the time reconfiguring the room behind me in order to hold the resin printer so I could get Dave and Julian in here and they wouldn't be choking down resin fumes. And I have been working on the circuit that we've been breadboarding. See, the TB303 is a very well understood diode ladder filter or transistor ladder filter. If you think about the difference between a transistor and a diode, there's just one extra layer of silicon on it, right? So the PNPs that I have, the NPNs that I have, I can use those as diodes. And that's essentially what Moog does in their design. This is not the, sorry, Roland, was it Moog? I think everybody's talking about Moog. The TB303 I'll say from now on. I won't put a parent company on it. But this is a mathematical analysis, which is essentially what electronics boil down to. If you really want to know how electronics work, you boil it down into math. It is unfortunate, and not all of us are good at math. I'm leading that pack. I'm terrible with math. I can do math, but I'm just not great at it. So anyway, the TB303 uses this transistor ladder filter, and this analysis here from Tim's Inchcombe. Tim's Tincombe.co.uk synth Moog ladder. Anyway, this is the fellow who did the analysis, and he's got in here, I'm trying to scroll to it in a good way. In here, he has all of the analysis of the different structures that make up your transistor ladder filter. And he specifically talks about the TB303, which is this design right here. We have a resistor going to the bases here, and then we have a VCC coming into the top, and that gets filtered down through 3 diodes. Well, on each side, on the resonance side and the regular side, and you've got your 2 inputs here, and then you have current control here. The way that the diode works in small signal land is there's some type of reactance that is involved with the amount of millivolts, and the more current you let through the diode, the more it's going to allow through. So you have multiple stages in here, and you have the current control over this towering circuit. Now, this is just a model that will show you how it functions. Let's see. I'm trying to get you guys to where I am. This is the actual circuit, and similar to what Acid Labs has on their board. Now, we haven't gone totally specifically into the control area here, but I would wager that things are just scaled slightly differently in order to allow for control voltages to control some of these parameters. In this schematic, everything is pulled over to the right to show you the controls, and it makes the circuit design, the sort of topology layout of the circuit design, harder to glean because they've kind of crammed all the components in and then moved all of the controls over to the right. But there's some type of resonant feedback that comes into this structure here, and we're using Q11 to control the amount of current that's going through this tower. And then I guess, I don't know, I'd have to do more analysis on this in order to figure out what the hell is going on, because there's a lot of weird stuff going on here. But you control resonance in this sort of feedback area here from R97, C23. That's sort of controlling your feedback, and then your resonance feedback. And then you have Q11 sort of bleeding out the current to ground, I guess. It's a weird one. But in addition to the Moog design, I'm going to say Moog, I might be wrong about that, Moog design, and the designs from the paper, we also have a Hajiwo design. And I don't know where Hajiwo got his original topology from, but the Hajiwo design has much simpler structures to control everything. The Hajiwo design is interesting because what it's doing is it's using this transistor here to control current with the voltage going into this op amp. So you have this 33K and 2.2 biasing your 2 ends of adjustment, and then you have a 100K swing back and forth. That's going to translate into a millivolt level signal. So you have millivolts coming out of the front of this thing, biased by the 33 and the 10K, and then we have a 10 and 10 mixing in from a control voltage if we want that. I don't have a control voltage, so we just have my knob that's creating a specific voltage level and comparing it to ground. And I guess there's a 10K going to ground. I don't know what that affects. But anyway, we compare it to ground, and so we get a millivolt, actually we get a volt signal out of the end, because it's 33 and 10. So we get a volt level signal out of the end, and then we divide it with a 33 and a 2.2 down to a millivolt level signal that's biased for this transistor right here. So this transistor right here is going to allow current to flow through the 4.7K from 12 volts down through the other 4.7K to negative 12 volts. So we have a loop here, right? We have 12 volts going down on these two through a 4.7K that's going to be a current limiting resistor. So the total amount of current is going to be limited to a certain amount. So whatever this thing isn't taking up, the other side is going to take up because it's biased between ground and negative 12. This thing is, since it's an inverting amplifier, it goes from negative 12 to positive 12, and it flips it. So whatever's left over is going to be flowing through this transistor over here. And actually, if I take this circuit, we'll do that in a minute. If I take this circuit and I replace this whole branch with a 10K ohm resistor, we can measure the voltage across it, and we can see a nice swing of voltages coming out the other side. And when you measure the voltage across a resistor, you're getting a reading of current. So we have 12 volts and a 1K current limiting going through a 4.7K, and that's being contested by a 4.7K through 2.2. And what that'll do is that'll change the frequencies that this filter is sensitive to. Have I seen it do that? No, it seems to do nothing. It seems like it does nothing. In order to try to see what frequencies it was sensitive to, I used a circuit that I know from Mutable Instruments, Emily Gillette. And Mutable Instruments, oops, that's the wrong window. Space. Okay, this is Kinks. Actually, I think I have Kinks open somewhere. Yeah, there it is. So this is Kinks, and Kinks is just a little module that allows you to do some, cute circuit tricks with your control voltages. So like you can invert it, or you can have only the positive, or you can have the positive turn into negative and fold over, or you could do square, triangle, weird stuff, blah 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 blah. Right? You do all these cool little op-amp tricks in order to create your unity gain control voltage manipulation tools that'll help you make your sounds sound cool. Right? There's some neat stuff that you can do, and this is a great example of analog circuit design in sort of control signal, in the realm of control signals, and like what resistors you need and what type of op-amp circuits you can combine. This is a great example. It's a great intro to this stuff for me. One thing that Kinks has is a noise generator, and so the Kinks takes two off-the-shelf Jelly Bean 3904 transistors, and it uses one of the, I guess, base to emitter leakages to make a millivolt signal that will then, boost itself on this 4.7K to ground. So again, we're seeing very similar values here. 4.7K to ground biasing a transistor, or going through a transistor. Anyway, that is turned into DC, and then it is amplified by this op-amp. So what I've done is I've taken this circuit, and I've created this circuit, but instead of the 1.5 mega ohm resistor on the feedback, what I've done, what's up, Gamer Bino? What I've done is I've put a 25 turn adjustment rotary potentiometer on that. There's little blue things that you put in for like tuning stuff, right? It's just a little tuning potentiometer. And so what I was able to do is turn noise into exactly the right amount of gain to go into the audio system of the synthesizer. If you guys remember, you probably don't. We figured out that the difference between, well, okay, that's not the right one. I don't know if I have it open still. Yeah, I don't think I have it open. What I was able to do is determine why Acid Labs designed this circuit in a particular way. And the reason behind it is that they have their VCO, but then you want to be able to output that VCO. The TB303, the actual original device, doesn't output that audio level specifically for modular synthesizers. So what Acid Labs had to do is at certain stages in the original TB303, they had to take their voltages, turn it into plus minus 2 volts for audio signals, or plus minus 10 volts for control signals. And they had to output it and input it back in, just using the plugs and stuff, in order to create their modular synthesizer module that would be, scalable and usable in a modular synthesizer setup. So that's all well and good. plus minus 2 volts means that I can inject that directly into the ladder circuit, and then presumably I would be able to take a fast Fourier transfer and figure out what frequency my freaking thing was set to, right? What the frequencies and the cutoffs were, and I'd be able to observe that. That apparently was not the case. I don't know what's going on with that, but for some reason, none of that stuff worked. And I can show you guys what I've been working on and how it's not been working. So here, let's turn the scope on. And then taking a look at the circuit, what I've built here, I've tried to spread out. I bought 3 new breadboards because the old ones were really, really frustrating because those little pinchy contacts go bad after a little while. You can't really bend them back. They're all made out of very cheap metal. Okay, I guess we'll just leave thermals off for a little bit. We don't really need thermals. Nothing's getting hot. So I have my input and my output over here. The input is coming from the frequency generator, which should, by all means, it should be on. I don't think I have the channel activated. That frequency generator comes in here, and currently I have it routed. Is that the output? No, the output I have plugged into an attenuator. Yeah, here we're reading the output on channel 1. You can see I've adapted everything over to the breadboard because it makes working with this stuff so much easier. Okay, set the record straight as if I was actually suggesting you set your subboard on fire, making a pun about burn the subs. You have to be specific on the internet. Yeah, the thing is, like, the laser already burns, so we're there. We've done. There's a reason I said burn the subs and not any other of a number of titles. Okay, where's my focal point here? I need to actually focus on the electronics. All right, so here's the deal. So I am plugged in. That's the input signal right here. If I want to route noise to that, I can plug into that over here. I don't have power on yet. Hold on, let me turn power on. Boop. All right, so, oh yeah, okay, so there's our signal. So this is at the output of the filter. We're actually able to see a square wave. This would be the frequency controlling stuff over here. And then this is resonance. And this one is gain. This one is just input gain. So that's very, very sort of milquetoast input gain control. That's what that does. It just lowers the gain. This one is resonance. It's the only one that is effective. It does weird stuff to the wave. It doesn't really appear to control resonance. And then this one, supposedly, is the frequency through the transistor ladder filter, but it doesn't do dick. It's not doing anything. So my thought was, well, and by the way, I put this stuff together piece by piece. That was the way that I got it all to run. So I was able to put together the current control stuff with its 2 transistors here, one of them connected to ground. And if I cut this off, this will cut off the output. So there's no frequency running through the ladder filter, so nothing is happening. And if I take something like a 10K resistor like this one here, and I put this up to 12 volts. Actually, we should make sure that this is 10K. I don't want to blow up my circuit right now. Let me just check to see that that's 10K. I got my multimeter probes over here, and those are connected with just these little adapters, so I can plug them into the board. It helps a lot to be able to do that. So if I plug this into just the resistor, and I got to go to ohms on the multimeter. Oh, this is a 4.7. Well, it would be 4.7 and then through the 1K. I mean, we'll see enough. We'll see enough through this. I just don't want to hurt my transistors. Chat. Let's turn thermals on and see if I'm hurting my transistors. So if I take that 4.7 and I go to positive 12 volts. So positive 12 volts here. By the way, I set up this breadboard to have all of the appropriate voltages. I had to cut these wires because the breadboarding kits don't have stuff that properly bridges these voltages. Sami El Hadri, welcome. So yeah, let's 4.7 into, this is the, these are the transistors that make up the Hajiwo circuit's voltage control. And we can look at the voltage right here, and I can hook the 4.7 up to it. So now what we're doing is we are measuring across, well, we're measuring across some weird stuff, but we are measuring the voltage essentially from this junction to ground. So that junction to ground, and that'll give us an idea that there's current running through there. And you can see right there, it swings up and down just like that. Up and down, back and forth. If I change my ground setup from the scope to be -12, well, actually positive 12, let's flip the whole script. So my ground wire is now going to that junction, and then my positive bias is going up to 12 volts. And we're measuring the difference between the two. And so we see here we're at 12 volts. And if I adjust, oh, damn it. You know, I did it with a 10 kilo ohm resistor and it worked perfectly. I don't know exactly what I did though. Maybe we could go negative. Positive 12 to this. Actually, is our ground? No, our ground's not from ground. The ground is made of ground. I don't know, I was able to get it to actually go. Let's find that 10K. Let's find a 10K. I forget exactly what I did, but I was able to get this beautiful swing back and forth. This beautiful swing of the voltages. My tweezers are somewhere in the fray here, and I would like to find them. Oh, they're there. Way over here. Finally, ground. Groundy. Very earthy. All right, let's find a 10K. So I'm going to go back to these probes. Let's bring them over here and just put them on an area of the board that I'm not using. I can plug this in. Wait, this is the one I took out, I think. My problem with these tweezers and resistors is that resistors are round, and so these tweezers just eject the resistor. I need slightly grippier tweezers. But the problem is my grippier tweezers don't have the long handle. I need basically a pair of these, but with like, I don't know, silicon rubber on the end. That one is 2 mega ohm. That's gonna... I want to use something with a 1, like 10K, 100K, because then if I use a 10K or a 1K, I'll get better numbers out of the other side. 3 ohms. No thanks. No thank you. I'm good. This one's taking a trip. See you next fall. 150K? I don't know what happened to the 10K that I tested it on. Maybe I used it in other parts of the circuit. Well, you guys saw it with the other one, though. Little cups. Yeah. Just slightly more grippy so it doesn't fire the resistor out at 100 miles an hour. $330K? That's not really going to show us anything. That's going to be a little bit too resisty. All right, let me get a 10K. I'll just have to get one. I got plenty of resistors. So this is the current control of the ladder filter. And what it's doing is we're taking a loop that has a current limiting resistor on it, and we are biasing a parallel path to that current limiting resistor. And maybe the 4.7 would have been a good idea, but it needs to be above 4.7 to operate properly. This is a 1K. That's an alternative. But I had good luck with 10K, which are these. So if I take a 10K ohm resistor and I measure the voltage across the resistor, and this would be from positive 12 volts to negative 12 volts, because that's where our voltages are running. So I can bend these down directly and then clip off the ends with my Nipex. Saw a commercial for Nipex. So weird. I guess they're popular with mechanics and stuff. I bias that to positive 12 volts through our current limiting setup. Positive 12 volts through the current limiting setup. And I measure the voltage at the resistor. I want to say verse positive, but maybe it's verse negative. It is not. Measure it verse ground. Oh, come on. Making a liar out of me. Doesn't let me... Oh, I see. There we go. You kidding me? Let's wiggle some stuff and see if I've got it set up right. So that's for ground. What about to -12? No, that still doesn't do it quite right. Let's see, that's -12. That's this one here. If I reverse them like this. That's funny. I had it work, I swear. I'm not lying, I had it working. Maybe it was a 1K. Maybe I was using a 1K. Pace conform? What are you talking about? 2 4.7 in series is almost 10K. How are you able to know what the circuit does by looking at the diagram? Well, working with the circuits and knowing how to do circuit analysis. I've had college courses of this, and you get used to certain structures, and certain structures do certain things in analog circuitry. So the more you work with it, the more comfortable you become with the sort of, yeah, like you said, blocks of functionality that certain things bring to the table. Now, sometimes that means redrawing a schematic over and over again in order to figure out exactly what's going on. But generally, your familiarity with it comes from working with the circuits in things like math problems and also just working with them IRL. But everything boils down to math. Analog electronics is math with a little bit of a sprinkle of a little bit of environmental conditions on top of it. So I don't know what the hell a pace conform is. So I don't know why I'm not getting anything happening on this resistor. Maybe if I put it in 1K, things will be different. Because when I was building this, I put that together and I ran that, and it was doing exactly what I thought it would. I was able to move the knob, and we could see the fancy, oh, that thing. Oh, yeah, no, I'm not using that. Because if we're going up and down to 12 volts, if we're going up and down from the rails, it's just the size of the resistor. So I don't need to grab the extra tool. I did use it when I was building the circuit, but this is generally fine. All right, let's try this with a 1K. That means it'll be a little bit more, I guess, hot. I don't know. I'm just trying to replicate what I did when I was working on the circuit originally. 1K to 12 volts through the one leg of the transistor. Measure the voltage across the resistor. We get 12 volts. Where am I plugged into? I am plugged into -12, and I made labels for them. I got McDonald's from DoorDash, and it was only $75, but I took the label off of the DoorDash and I put it onto this thing, so I know where my voltages are, so I don't mess up. So anyway, I'm putting the probe lead on the junction of the resistor and the transistor that's bleeding it down to ground. It's bleeding it down to the 4.7K to ground, rather. So a certain amount of current is going through this 4.7K, it's current limiting. A certain amount of that split is going through this resistor here that hooks up to the rest of the circuit. And then the other is going through this right here, controlled by this knob. So we have a certain amount of current that can flow through. And again, you know, this goes back to my MS Paint notes. You take notes about stuff and you come up with theories and you test it. I know that this structure right here is just an amplifier. Or, well, it's actually damping the signal. It's keeping it from blowing up our lovely little generic jelly bean transistor over here. These things can only take so much. They can't take 10 volts directly in, right? So you've got your 10 volts here, and then you've got your your negative 12 to positive 12 volts, you bias that by putting resistors on the ends. So actually we have a 135.2 kilo ohm resistor from here to here. So that 135 kilo ohm is the amount of current that's flowing from positive to ground when you turn that on. However, we also have a bias right here. And so we have a certain amount of that resistor sitting on top and a certain amount of that sitting on bottom, forming a voltage divider and giving us with limitations on how up and down you can go. You can't go until there's 0 ohms to negative 12. You can go until there's 2.2 kilo ohms to negative 12, right? So you swing that voltage up and down, you put it through a certain amount of bias. So we know that op amps are, what is it, a ratio of V1 and V2? I'm not saying which ratio because I don't remember which one is which, but it's a ratio between V1 and V2. And then it inverts that signal over here. So this is now going into the negatives, which is a little weird because we're putting a voltage divider on it to ground. So that would actually be voltage divider to ground. I don't think that's inverting it. Maybe it is. I don't know. Either way, this op amp inverts it and it damps it. So we have a 10K and a 10K. So we have unity gain coming in from there, which means plus minus 10 volts. Over on this side, that's a little weird, but it does mix with this knob, wherever that knob is set. Then we go into this circuit where we have another voltage divider here. So 33 2.2, that's again that bias again. So 33 to 2.2, and it is used in order to bias this transistor. This transistor has a resistor on top of it, and then our voltage source up here, which is very similar to what we have. We have a resistor on top, and then we have a voltage source. And we know that because of that paper that has all the equations breaking it down, we know that this thing functions off of the amount of current that's running through the ladder. So the current running through the ladder dictates what frequencies can be seen by the circuits. It's a weird structure. It's a very interesting topology. It's very confusing though. So we have biased from ground to negative 12. Remember, electrical engineering, it's all potentials. So it's all, where does this sit in relation to this? So the ground is not our lowest point in the circuit. Ground is right smack dab in the middle of positive and negative 12 volts. In fact, our circuit could be thought of as negative 12 being ground. Ground would be 12 volts, and then positive 12 would be 24 volts. You can think of it that way, although generally we think of it as 0 being the number line. So we go positive and negative. Negative is a made-up concept. But anyway, what's happening here is this 4.7 kilo ohm resistor can only let so much current through. Two branches leading up to 12 volts, and only so much current. Remember what we do with light-emitting diodes, and these can be thought of as a diode-like structure. So with an LED, you would have your positive voltage and a resistor, and then the LED. That goes to ground. And only a certain amount of current can get through there. The current limiting resistor is important. It only allows a certain amount of current through the circuit. So in physics, it would then stand to reason that the amount of current would structure itself between the two paths in order to create an equal amount of feed down through here. It's like two reservoirs of water feeding through the same. Shut up about water. Why are you always talking about water? Everything is always water with these stupid fucking circuits. It's always water. It's not water, it's electrons. Ugh. You can think of a capacitor like a water balloon. Anyway, so it's always water analogies, but you know, a certain amount of flow is going through that 4.7 to negative 12, and so if you allow more flow from here, there's less flow from here. It's a push-pull between these two. That's my understanding of how this circuit works, and you know, generally the transistor ladder, it's however much current you let through changes the reactance of all of these devices up here. Yeah, beings of mostly water. Okay. So if I put hold on. So if I put that 4.7K here, we'd be able to see exactly what goes on by measuring across it. So that's essentially what I'm trying to do here. I probably should use that 4.7 that I found. Anyway, we got a 1K, which will exaggerate it a little bit. That should come up on the scope as a varying voltage level depending on where the knob is. Why isn't it working? Ground and positive? No. Not between ground and negative. Did my circuit break? Is that what's going on? Power's on. In the past, I was able to move this and I would see it changing the voltage level. Did it blow up this transistor again? In the past, I've blown up the transistors for this and that gave me, oh, that's hot. Well, it's not terribly hot. I'm just maybe measuring it wrong. If I put the probe at positive and then we measure it based on this, what does that do? Nothing. Why? Why? It's getting frustrating out here. I'm not hooked up properly. No, I'm hooked up. We saw this adjusting before. Let me get a 4.7K on this. Find that 4.7K. I think that was this one. Oh, no, that one's gone. It just these resistors are round, and so when I go to grab one, they kind of fly away. All right, let's measure this one real quick. Can't have the measurement on screen, unfortunately, with this multimeter. That's a 2M. That's not really going to help us out. Let me find that 4.7. I need like an AI program that'll scan what's in the camera's lens and find out what the bands are and just tell me so I can point it at a pile of resistors and know which ones are which. This is another 2M? What the heck? What's going on with all the 2Ms out here? This one was a 10K. Or there's a Lego man that had its arms outstretched, and you would put the resistor in its arms, and it would tell you the value. This is another 10K. Where do I keep coming up with these? The first useful use of ChatGPT. I don't know if you need ChatGPT for that. I think Microsoft OpenCV could probably do that just fine. Just identifying like the parallax and then figuring out what the bands are in terms of color based on sampling. That's more of a Microsoft OpenCV. Okay, 4.6, here it is. Okay, so this is the 4.7K. And if I put that to 12 volts, double check, that is 12 volts, positive 12 volts through a 4.7K. This does not have the additional 1K on it. 12 volts through 4.7K, and then I measure from point to point. It's not heating up. See, I should get a nice swing of values, and I did in the past. But it doesn't appear to be doing anything right now. This is weird. It's not moving at all. We saw it moving before. Well, let's flip our biases. Let's go here, positive, ground, and we're measuring across the 4.7K, and I'm not getting anything. Feels like I blew up a transistor. There it's moving a little bit, you can see. It just barely kind of moves. So let's check earlier, and I'll go to ground with this one. So now we're biased to ground. And if I look at the output from this circuit to the transistor, actually we'll go before that. This is just the output from the op amp. There's our swing. It's actually not that impressive. Go down to 2 volts. There you go. So from -1 to negative almost 2.5. It's like -1.5, -2.5. That is a strange spread, buddy. That's a strange one. So that goes through a resistor, a voltage divider, and it becomes even more pathetic. So there it is, from negative like 150 to negative even less than that, because it's gone through a voltage divider, right? Dr. Noisemo, how's it going? PayGoogle.com, resistor scanner. Somebody's already done it. Ah, I don't want to pay for it though. It'll probably take over the webcam too. Yeah, it's probably like one of the Google things. Okay, so if you guys see here, my structure, I have decided to break out each op amp to be just one op amp per task. So over here, I have sort of the shutting down of the other op amp so it doesn't become unstable. Oh, it's free. Oh, I don't know if I'd be able to read these. So over on this side of the chip, we have our op amp, right? So we have in-out ground, and then we have our power supply. So I have a 10 kilo ohm resistor sitting right here going out to nothing. That would be our CV input. I have our feedback resistor across the two pins right here, and then our output is over here. So our output goes out and over to, well, actually our negative input comes from the potentiometer that has our positive bias right here and our negative bias right here. So that goes positive to negative 12 volts across this potentiometer, and then this right here becomes a voltage level that is going to be scaled between these two resistors. It's going to go through the transfer function of these two resistors. So on the output, I have a 33K and then a 2.2K to ground. And so we're measuring across those two in order to see what the output from the op-amp structure is. And this is probably what it should be, is a pathetic little negative potential here. Now the thing is, this is in the negatives, which means it's below ground. And if it's below ground, what that means is that we are positively influencing a transistor that goes to ground. Our electric potentials are positive here, negative here, and especially from here too. So this is actually above this. So it will bias this way and current will flow down through it. So by all means, I should be seeing some kind of a voltage swing here. And we are. It's very pathetic, but we are seeing it. So that's what's biasing the transistor. Now, is the transistor working? Good question. So if I go to this right here, which is a 4.7 to positive, through that transistor, I mean, of course, I'm not really seeing anything because we're biasing to ground. If I bias it to... Biasing to plus 12 isn't going to do anything for me. The only problem is that I can't... we can't see that much resolution of that here. There it moves just a little tiny bit. I feel like it should be moving more than that. But we are referencing it to ground. Although we're not referencing it to negative 12, but you can just see it barely kind of touch that. I feel like it should be stronger than that. Maybe this transistor's burnt out. I might have burnt out the transistor. That's always a possibility. Because we're looking at it in relation to ground. I mean, really, we should be looking at it in relation to negative 12, but that's going to be such a huge swing. Actually, it's not. Oh yeah, whoops, that's not. You can't really see it doing anything there. Plus 12? That would be the comparison between positive 12 and the other side of this thing. Yeah, there's no movement at all. Although, maybe there should be. Is it possible that there's something wrong with my setup? Because then the other one would be comparing the current through this resistor. That one doesn't move at all either. Let's replace this transistor and see what happens. I didn't stage any of this. Something is just not working properly right now. My frequency bias control has never done anything. What was heating up? Oh, just from my handling it. Yeah, and then that's our feedback resistor. Okay. Need to work on lenses for the thermal microscope. All right, let's stand up. My legs are feeling the stool. Okay, so what I'm looking for is another transistor. I have a little bin full of them. Where are they? What have you done with them? Where are my transistors? Where are they actually? They might be on the desk. Where are you? Yeah, I had to swap them out a couple times because I blew up a couple, which is good experience because it teaches you how this thing fails. And it looks a lot like Dave's synthesizer, which is why I now have a theory, which I don't know about how much water that theory holds. By the way, later in this week, either Thursday or Friday, we're going to have Julian and Dave here. Assuming that, you know, things don't go totally awry, but I don't think they will. Well, Julian and Dave here with their synthesizer stuff, which is why I got to get this done. So I've been using the BC337s. They're a little bit different than all the others, I guess, but generally these are pretty jelly beany kind of parts. I guess the B designation, the BCs are pretty British, I guess. Am I allowed to say that? The BC337, I don't know. It seems pretty jelly bean. Some of these circuits call for 3904s. Some of them call for very specific transistors. I'm using BC337. On Thursday, I will have a transistor tester that I can use in order to make sure that these are matching pairs where they need to be. So Hajiwo's circuit does not specify matching pairs, but I have a feeling some of these probably do need to match in order for us to get proper filtration going. By the way, the whole purpose of building this circuit is to build an analog to the transistor ladder filter that is used in Dave's synthesizer. So once I build an analog, I can study it and figure out exactly what fails and when. Part of that is learning that these three transistors here might be the ones that broke, not the ones in not the matched pairs. It's possible, but we did swap in this thing for a new one, and all I see on the ladder are positive voltage levels, which is the same thing I see if I do testing up here and try to look at parts of the transistor ladder. All I see are just these positive. Oh, I turned output off. Hold on. Output on. You see, we see just like 12 volts there, right? Because that's all in the current control realm. And I'm not really seeing much of a voltage difference between those two with the scope. And I found that to be true on my analog circuit. Although I'm still kind of trying to vet out and figure out if this thing is functioning properly. I did get more functionality out of this than I did Dave's circuit. So pluck that one, put a new one in. This one might still be fine, but we just want to make sure. And then measure from, let's see, from ground on 12 volts to our probe on that. So turn that circuit on. Get a little bit of negative bias and still nothing moving. Let's check over here. We got to zoom in a little bit to see that. Not doing. It ain't do nothing. Why are you like this? Why are you like this? I can isolate it from the other transistor if I pull that one component right there. I don't know what that's going to do for everybody else. If I take that leg out of that one, that should be okay. Now what? I can slightly see it moving, but not much. What happened here? How come I've lost control? What was I biasing over here? Maybe that's what I lost control of. I'll put this back and then I'll adjust the pot. I think maybe my addition of the pot did something to the rest of the circuit. I tried to add like a little adjustment to one of the facets of it. Oops. Actually, let's take it back. Let's take it back to the roots and get this out of here. So what did I do here? I have a pot that's taking up these 3 pins. Those two are combined. This one goes down to ground. So from this leg, why did I do this? Why did I do this? It looks like I can change the 4.7K. Well, let's just put a 4.7 in there instead of this. That's right. I think I did that in order to swing the to get more control of it, and then that influenced it in weird ways. And I blew up a transistor with it. So I'm just going to remove that part of the circuit and put a 4.7K to ground on this, to negative 12 rather. Which that's the 4.7. I guess I'll have to steal this one. Put that to. So let's see. That would be. Here to here. I keep saying ground. 4.7 to negative 12. So there. Now we've got the original circuit in here. So if I look at, let's just get, which one of these? Is that 10K? Ah! Also launched it. Yeah, it's 10K. All right, let's go back to the 10K, because I think this will work just fine. I forgot that I added that little resistor, the variable resistor to that. $10K, and then we can do ground at positive 12. That might go into the negative, but whatever. Like that. And then if I turn this on, whoa. Why did it read point? What the hold on. Something weird happened. What did I do? Is there heat on any of this stuff? No, no heat. The power shorted out. Why did the power short out? 10K to positive. I've got ground hooked up to plus 12. Maybe that did it. But hooking up to plus 12 isn't going to be the thing. Here to ground. There we go. Now we're at 12 volts. Jeez. I don't know what I did there, and I could have broken a bunch of stuff by doing that. So we don't see it doing anything, which might not be the indictment that we think it is. Yeah, I was getting like a full plus minus 12 volts on the thing when I tested it the first time, chasing that dragon ever since. Because, yeah, this isn't showing any evidence of current flowing across changing. Although, whoa, okay, our voltage level dropped. Okay, what happened there? Something is contacting and shorting out. Are the wires getting hot? No. It's my power supply tells me how much voltage and current goes through the circuit, so you always give it a glance. You always give that a glance when you're testing things. Because every now and then, something like that will happen where something shorts out. And I don't know which part of this is shorting. I don't think it has to do with my inputs. There's ground, and there's negative 12. It could be the two alligator clips coming into contact with each other. That's always a possibility. Let's see. This junction here is what I changed. These are the emitters connected to... the emitter connected to 4.7K that goes to negative 12. It's not really that. There aren't really that many circuit paths here that could be splitted like that. Anything crossing over in a weird way. Looks like we're good. All right, let's power it up again. 1 volt, 1 amp. What's going on here? Who's shorted out? There's 12 volts. Weird. Yeah, I don't know what was doing that. I guess my scope was shorting something. So from there to there, we've got this biased voltage level. This would be on ground. Not negative 12. This is plus 12. I'm not drawing any additional current from there. And I'm trying to see the bias across the resistor. Looking at it from ground, which is a weird perspective, but... And this should swing back and forth, assuming we didn't blow anything up, but it's not really doing. Let's check over by the op amp again, where our signal will have the most gain. Okay, so that's still functioning. Yeah, I don't know what... Okay, so I'm confused now because at some point when I was building this, I put a 10K ohm to positive 12 as if to basically like mimic the other side of the ladder filter, and I was getting a big swing of current across the resistor. And if I put like a 1K up to 12 volts and then I measure across a 4.7, let me get a 1K resistor here. Maybe we'll do that. We'll try that. So I'm going to put the 4.7 in to simulate the other side of the circuit, and then put a 1K on there that I can measure across. God, the round shape of these are very annoying. Gotcha, Base. How's it going? Demi, how you been? All my pepper plants down here failed. We bought store-bought peppers, but those are growing really, really well in this sort of terrible hellscape that we have in the Northeast lately. 1K. I guess I'm going to have to grab one. We grabbed a 1K, so there's probably a 1K floating around here somewhere. Again, I need that that Google program that lets you see all the different values of resistors that are sitting around. I have the multimeter hooked up with leads that go to the breadboard, so I can read it over here, and I can hook it up, you know, on something that makes good contact. It's still kind of fiddly, though. That's 2M. This is the most useless resistor. In V equals IR, we should have seen... I mean, we did see a little bit across the 10. Maybe the 1 will show us a little bit more with that 4.7 in place. Okay, OL? That's not right. LOL? There's our 1K. Okay, this is the 1K. And so I'm going to hook that up here. And this 4.7 goes up to positive 12 volts. So now we're simulating the diode ladder circuit. Although, I mean, I guess these allow everything to flow through. It depends on the frequency, how much they allow to flow through within the amount of current that they have. We're simulating this whole thing as a 1 kilo ohm resistor. So I don't know if that's really that accurate, but what I need to do is then take ground and power, ground and our feed or whatever, and hook it across this resistor. And that'll give us a readout of how many amps the circuit is utilizing. Through the lens of a 1 kilo ohm resistor. I mean, if I did a 1 ohm resistor, we'd probably get much larger numbers, but it looks like output is still on. Why is this never working for me? I really need... The frequency generator really needs a better home. I need a better BNC cable to go between these two. I need to hunt for a better BNC. Because every time I touch the controls, it moves around. You just like glue it to something. Okay, let's see. So I adjust the voltage into the transistor. Fucking nothing happens. What the hell? Why do I not have any agency over this crap? What's my, like, scope settings? It should just be DC coupled. Yeah, DC coupling. I'm not AC coupling this. Certainly not ground coupling it. Under DC coupling, this should be perfectly fine. So, what the heck, man? Power, ground, across. Yeah, we're getting a voltage reading at, you know, of like 1 point something volts. But I'm not getting anything happening here. And that pulls into question whether or not the transistors are functioning. I'm going to redo the I'm going to replace both of these because we might have blown them up. I'll just try it. You can also diode test the transistors to see if you blew them up, but I've got plenty of these things. They're not really being used for much, so BC337s, I'll just keep trying them. I have a feeling this is what happened to Dave's thing as well, is that just shenanigans caused the transistors to blow up. They're the most sensitive part of these circuits. So I'm going to move this one out this way, and then I can skip over this line here and go 1, 2, skip over there. There we go. That would be the output. And then the input from the knob goes just across the 3 leads as they are, but I'll spread these a little bit so I get a little bit more control. Just got to kind of, hey, spread them a little, leave room for the Lord, you know? Spread them just a little bit. And then I can go 1, a 2, a 3, and that hooks up that side of it. So we got 4.7 going to ground over here. We have our voltage divider right here, and then we have our voltage input source coming from the op-amp. Op-amps are a lot more robust than a singular transistor sitting out in the wind. This is as simple as it gets. Output on. So now we have a signal that looks exactly the same as it did before, and it functions exactly. Okay. All right. So maybe nothing is broken in here. Maybe all of these transistors are totally fine, and it's just me. I don't get what I'm doing wrong. I should be reading across this 1K, I should be reading a swing in current from positive 12 volts. Is my scope dumb? No. Why is it doing it like this to me? Let's put a 1 ohm resistor in there. Let's go for broke. I'm going to put a 1 ohm in there, and that's V equals IR, right? Where are my resistors? Am I getting that backwards, V equals IR? Should I be going for like a larger value? I don't think so. I think a 1 ohm resistor should show me a huge voltage swing across it. Maybe we'll do like a 10 ohm. Here's a 10 ohm. Not a lot of use for these 10 ohms. If these 10 ohms could talk, the things they'd say. All right, so bend those down. Let's get that one in there and just test it. We haven't even started in on the circuit. I'm just trying to prove to you guys that things are functioning properly. But at least this highlights a little bit of what I was seeing in my own personal testing of the circuit, is that when this part of the circuit fails, we get a lot of the results that we see in Dave's circuit. So I guess that's our little bit of rest assured. I mean, we're not going to see a lot of voltage difference across just a 1 ohm resistor, right? It does need to be a big resistor. Although those current sensing probes have very small resistances too, so you got like 0.0 something. All right, output on. Oop. See nothing. Yeah, see nothing across this. Why must I continually fail? What do we fall down, Master Bruce? What do we fall down, Mr. Bruce? Why is this not doing anything? I mean, if I go to like ground, we get a big negative. I don't see any swing on that. Am I dumb? Is that what it is? Am I dumb? If I take a 2M, take a 2M and look at the voltage across the 2Ms, that's going to give me... I'm going to... Hold on. Current. It would be V equals IR. So the voltage is the current times the resistance. If I have a big value of resistance, then I should see, for a little value of current, a big value of voltage. Okay, so I'm going in the wrong direction. I think I'm going in the wrong direction. I think if I put a big resistor in there, I'll see a big swing, right? Cosmo Questix! Hey, how you doing, Cosmo Quest? We're still working on Dave's synthesizer. It's really pissing me off, but I've created an equivalent to the circuit. Haji Wo, who's a YouTuber that makes cheap modular synthesizer stuff, has a nice, simple resistor ladder filter. Now, the resistor ladder filter is something that I guess Moog came up with. It's not Roland, but it's for the TB-303. It's the acid house sort of blade, that song. It has that kind of like acidy, progressive sort of thing going on with it. That's sort of this synthesizer. We've been trying to fix Dave's version of that synthesizer that's made specifically to be a modular synth. So it's supposed to go in with a whole bunch of other modules. You're supposed to be able to plug voltages back and forth across these things to control them. Dave's has been throwing me for a loop. I have no idea what's wrong with it, save for replacing every single freaking component on that thing. I have no idea what's wrong with it. So I built a version of the Hajiwo circuit. We did this last stream, although I've moved it over to this board, and I've been taking it in a piecemeal way. Build one section of functionality, test. Build another section of functionality, test. And so that led me to a lot of different testing yesterday and the day before, and I've been making some progress. We now that I've hit the stream start button, apparently we've regressed on all of that progress, and I can't even vet out and show that this part of the circuit works. This part of the circuit is designed to allow current through the rest of the ladder. So what happens here is you have your audio signal coming from somewhere over here, right? And this is the ladder. The ladder is made up of a bunch of diodes, right? So you have your audio signal coming in, and it goes through this transistor down to ground, I guess, or whatever. But it goes through the transistor, and it's controlled on this branch. This other branch over here is designed to do the same thing, but with resonance added. It takes your signal and it feeds it back through and creates a resonance, which is a really nice thing to do with audio. It's nice. Anyway, the point is, as you bias these diodes, they have a different amount of reactance and they have a different sensitivity to frequencies. So you have your frequencies coming in through here, being pulled down through this transistor, and then you have a certain amount of current that's allowed to flow through that ladder, and that creates a very nice cutoff filter that preserves bass. It's actually kind of a really cool thing. I barely understand how these work. I can give you that explanation, but it's not really going to give me all that much detail. In circuits, you have branches of stuff happening, right? So when you have branches of stuff happening, if you have a 12-volt source going through a certain amount of resistance, then these resistors are going to act as current limiting resistors, V equals IR. You have a certain amount of voltage, you have a certain amount of resistance, you only have so much current. So if you have a certain amount of voltage and resistance from both of these branches going through one resistor to a negative potential, you only have a certain amount of current that you can work with. So what happens is, through this 12 volts, through this 1K, through the rest of this stuff, you have a certain amount of current flowing through. If you allow more current to flow through this branch of the circuit, what's left is going to flow through this branch, and vice versa. So as you increase and decrease the voltage to this transistor, it is going to allow a certain amount of current to flow, and that controls your frequency of the filter, because the amount of current allowed to flow through these translates into frequencies that are allowed through. So that's the forest for the trees. Right now, I'm having a little bit of trouble displaying how current is flowing, because my thought is if you build this like this, then I would be able to measure across the 1K or whatever value there, and I would be able to display how much current is flowing through the rest of the system, or through this branch of the system. And we kind of got results on that. It was a millivolt level that went up and down, but it's not really working out for me. It's not really working out all that well. I'm not getting a very good impression of how much current is flowing. When I was building the circuit, I hooked this up with a 10 kilo ohm resistor, and I got a beautiful display of current running through. I was able to move the knob, and the thing went all the way up and down from like 12 volts. I don't know how I did that. I'm starting to question everything here. I had it working so well. But we've been throwing resistor values into this thing for a little bit, and I haven't been getting good biases across it. Of course, the more or less that I do this, I mean, if I remove that, current drops down significantly, actually. And if I put like a 10K in there, There we have 500 millivolts. If I adjust this, yeah, see, it only moves a tiny, tiny bit. You can barely see it. Does this thing have, well, okay, so what I can do here is I can actually take my multimeter and do current monitoring on that. So I can go to milliamps, change the lead over. Ow. Change the lead over. Jeez. 400 milliamps, hook that up there, and then from that 4.7 or whatever, I can hook this up in line. 22 milliamps. It is broken. Oh no, 9 milliamps. So gonna go back to 20? No. Something's broken. Let's see, that's 4.7. This leads back to the rest of the circuit. Yeah, it's like whenever I pick it up and move it, it changes. But these are brand new transistors, so what did I mess up? Brand new transistors, they're biased in a particular way. All the parts look to be in the right locations. Oh, let's look around here. The multimeter isn't exactly the best at reading this stuff. Maybe I have these reversed. I go this one here, and this one here. This may be the underlying problem that I've had with this circuit over the past couple weeks. Scope, where's my scope? There it is. Oop. I mean, is it on this scale? Is it on the microvolt scale? That didn't move when I moved it back, so what am I doing wrong? Measure a couple voltages here. So between ground there, why is it moving around so much? Oh, this is still in milliamps. Whoops. Volt. .8 to 11.9. That is moving though. Output over here. This is going to -12. 9 volts. There we have 10 volts. Going from ground, -2 volts, -1 volt. So 2 to 1 volt is coming out of this structure. And that is here. I'm measuring here. So 2 to 1 volt, that's to be expected. Assuming this thing can't swing in one versus the other direction, shouldn't I be humping the number line with this? But I can take this down to 0, and then it's 33 and 2.2. So it's going to be biased more towards negative. And it seems to the effect where I can't actually get it to be 12 volt. If I take this up to 33K, which is a third of its travel, I should be at 0. And I'm not. I'm at negative 1.3. Why is that? I should be swinging from 12 volts to -12 volts. Not fully, but at least just slightly influenced in that manner. I'm going to turn this off and unhook the output from the op amp. Where am I measuring? Why am I here? What if I'm here before that 33K? Although that shouldn't, well, let's test. Test everything. -11, 3 volts. Okay, all right. So this is traveling properly, and it's always fun to see. It's always fun to see that move when you move the knob, because it gives you an idea of where the voltage is going before the number display can actually give it to you. Okay, so this is going from 3 volts to negative 11. Ooh, that hit a nerve in my middle finger. Ooh, felt that all the way up my arm. Negative 11 to 3. Okay. I'm going to mark that down. Negative 11 to 3 volts. That makes sense. It's the third. A third of 12. And then we go 3 to 1 ratio, 3.3 to 1. So then, shouldn't that be, well, then we go 3 to 2 ratio on that there. Ooh, the 3 to 1 ratio out of there into here. So then it becomes negative 3 to negative 1. That's an odd one. Negative 3 to negative 1. And then on the output, negative 1.3 to negative 2.3. Negative 1.3 to negative 2.3. And then that's biased. Well, then it goes through another voltage divider. And after that, it becomes negative 0.1 to negative 0.9. That's a much smaller swing than I thought, but it's still there. Negative 1 to negative 0.9. And then it's compared to, well, we've been comparing it to ground. So it should, you know, technically it would be the other way around. And then that's where this thing is biasing it from ground to negative 12. So like this. That's negative, that's 18. 22. Oh, because we're measuring it from positive to fully positive to fully negative. So from 22 to 18 volts. Little 4-volt swing there. And then to here, it would be like 1.8, 11.9. Okay. And then now on the output, oh, there's no resistor there, though. Well, I need to actually hook it up to something for this to change. Tweezers. Where are the tweezers? Where do my tweezers go? What did you do with them? I found them. Okay. And then I'll look at it here. 11.2. 11.27 to 11.29. Well, that's the negative 12. From ground to that pin is what the... So it is adjusting. It's just hard for us to observe it. Oh, I also put this resistor to ground. Wait a minute. That's the positive 12. I guess the scope was just having trouble reading it. It's easier if we see numbers. It's 12 volts, and then to here, it's seeing the potential across that. 12.68 to 12.7. So taking that through the lens of the resistor value, we can see that that actually is the amount of current going through. Mathematically, technically this works. It's a little jank, but it should do something, right? Okay, so we got a better understanding of that stuff just by attrition. That still leaves the rest of the circuit not really functioning properly. So I have the ability to inject a frequency into this thing, and I have a plus to minus 2 volt signal in order to mimic the M303. The M303, you know, and modular synthesizers in general have audio signals, I guess, with a 4 volt positive negative, sorry, a 4 volt peak to peak plus minus 2 volts on the zero. And so I replicated that with the frequency generator, and that's what's being output by the frequency generator. If I hook that up, we can take a look at it. Yoink. And then, I don't know, ground. I want a ground bias because it's a number line. And then we go over to my input That's the output. Or no, that's the input. What's plus minus 1 volt? What the heck? This has 2 volts on it. Why am I plus minus 1 volt? What are you doing to my audio signal here? This would be the output. Wait a minute. The input's coming in over here. No, it isn't. That is the output. That's the output. This is the input. Input here, before it goes through any attenuation, is plus minus 1 volt. What the fuck? Okay, frequency... Oh, no, I don't want that. I want amplitude. Escape. Amplitude 4 volt. Okay, it didn't listen to me. Amplitude 4 volt. Okay, now we're plus minus 2 volts in inputting into this thing. So we had a big attenuation issue. I gotta hook up this thing again. Comes out. This goes here. Anything else needs hooking up? No. Needs to be hooked up. Boy, grammar's tough. But Ford's tougher. What the? Oh, whoops, that's wrong. My input signal's coming in through there. It goes through an attenuation where it reaches here. But for some reason on the other side of the diode, it is cooked. Why is it cooked like that? It's like biased. The attenuation works, but why it's like biased all the way up at 6 volts. Ground there. We have our signal coming in after attenuation right there. And this is attenuating it from ground to signal level, and then that's the output. That's what's in the circuit, right? Yes. So input to the top of a 10 kilo ohm, bottom of the 10 kilo ohms on ground, and then the wiper goes back and forth between those, and it goes through another 10 kilo ohm and a so a 1/3 operation again, and then it goes into the capacitor, where on the other side it comes out as a plus minus 1.8-ish volt signal. Is the signal generator silly, or do electronics just have a silly definition of amplitude? Yes. Yeah, amplitude 4 volts gives you an amplitude of 4. And I don't know, it just changed the values when I turned it on and off. I don't know what the deal is. What's up, Fatanon? How you doing? I know, it all gets pretty silly sometimes. I'm trying, though. Trying to get this filter working, and we're doing it on the breadboard. I just don't understand why there's such an offset. I guess other elements of the circuit are applying that to it. I don't know why I'm double jumping here. This is how I inject the noise signal. So right there, we're hugely off. We got a huge DC offset that I thought the capacitor would be dealing with. There's no DC offset on this side of the signal. Why does it look like that? Wait, it's like, what the fuck? Why does it look like that? This should just be our normal old signal. Resonance messing with it? No, resonance is doing nothing to it. So for some reason, it becomes this weird ramping signal here before it goes through the rest of this stuff. And there it gets a voltage bias applied to it by the voltage divider. Voltage divider over here applies sort of a 6 volt offset. That's what's going on there. And then it goes through everything, and it comes out with nothing, apparently. Oh, yeah, because I've got it hooked up over here to the speakers. Yeah, it doesn't appear to affect it as I thought it would. Well, we don't need it on the speakers because that's going to be very annoying. Let's put it on an output signal here. And I think that's this. Yeah, there we go. So there's our output. When I adjust the frequency, nothing happens. If I adjust the amplitude, we can see it controlling the amplitude as expected. And if I hit the resonance, it does nothing. It just does that. I don't understand. My filter appears to do nothing. Now, one of the things that I wanted to do was figure out if that filter control does anything. And so in order to figure out if the filter control does anything, what I can do is inject noise and then look at the Fourier transfer. And the Fourier transfer will tell me what the makeup of noise is. So we go to this Kinks schematic. We go to the Kinks schematic and we just make this leaky transistor filter in order to create white noise. And then, of course, we bias it appropriately to get the right voltage level out of it. So let's take a look at that. So if I, wrong one. So if I take a look at the output of the noise generator in reference to ground, there is our plus minus 2 volt noise. And we can cook that a little bit more. Let's cook it a little bit more. Let's give it a little bit more amplitude. It doesn't quite reach 2 volt with the bulk of everything. There we go. That's a little bit stronger. It does spike above and below, but this would be the noise from Kinks. Now, if we take that and we put that into a math function on channel 1, and we do a fast Fourier transform, I guess the center of 2, I don't know, the center and span I'm not sure about. And I don't think the scope gets into the audio FFT very well. Doesn't do a great job. Is there a different kind of FFT? Squirt, band pass, band stop, low pass, integrate, differentiate, logarithmate. No, I think FFT is our best bet because we're looking at the frequency makeup of this. So now I turn it on, Oop. And we get on kind of a large scale though. It starts at 800 hertz and goes all the way up to 7 kilohertz. But we can see that the components of our noise is noise. It's all of the frequencies, more or less. So if I take that channel and I put it on our output, after the capacitor, output after the cap, well, now we're a square wave, so there's, you know, things are a little different. We're a square wave, and so we have a spike in the frequency of the square wave and then all of its corner frequencies. We have all the derivatives of that frequency, which is why we see multiple spikes pointing downwards of where those frequencies are. Now, I'm going to give it noise. So I cut off the input. That drops down. And then I take noise and I inject it into the input. Okay, so there's our noise. It's going into the input, and we've got a transform coming out of it. Resonance, I don't think I'm seeing a whole lot going on there, although there's some weird lumpies when I get all the way to the end of it. But then if I adjust the frequency, nothing is happening. Why is nothing happening? I'm seeing little spikes in it, but I thought that I would at least get some kind of an impression of like an envelope of some kind as I move across the frequencies with this. I don't really see much of an effect on the wave, on the frequencies going in. We know our amplitudes are good. Well, why is that 500 millivolts? It's a little weird. Guess the rest of the circuit is affecting it in a weird way. So I don't understand. I mean, we saw you're not hitting enough voltage on your transistors. It might be down to the voltage on the transistors, like the bias on them. do we know that the frequency going in is actually changing? It's noise. It's white noise. And so we should be seeing a damping effect of different frequencies on this. Not to mention, if I do a sweep, here, let's do a frequency sweep so that we're not relying on perhaps slow calculating FFT. Get out of here. What is this? So I can just turn it off from that menu. Come on, get out of here. Separate those out a little bit. That means the number scales are going to be harder to realize. And then we are not doing noise. We're going to do frequency generator. So I will cut this one off. Cut off noise, and then we will take the generator and plug that in. And so now we have square wave versus square wave. And if I take it and I change the mode to sweep, and hit OK. What's going on here? Doesn't let me select. Mode. No, not you. Mode. Sweep. Is there like an OK button that I'm missing? Oh, I just hit mode again. All right. What the heck? So there it is, sweeping from a relatively low frequency up to a pretty high frequency. And the amplitude of either of these is not changing depending on where I set the frequency knob. So that frequency knob should absolutely be influencing what these waves are doing. These are general use transistors, so they don't need 4 volts would blow them up. Only Kinda Sorta. Thank you for subbing. Only Kinda Sorta has been subbed for 2 months with a Prime. Thank you very much. What's going on? Yeah, nothing's working. Nothing works. Nothing ever works. I don't know. I'm not seeing much of a difference between the amplitudes of these two as we run them through the gauntlet of this diode ladder filter. Why is that getting so hot? What is that that's getting so hot? Why are you warm? It's you. Why are you getting warm? It's not hooked up to the pot, it's hooked up to the filter, yeah. Been a roller coaster the past year, cutting drama out, full-time making my own game. Nice, 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 nice. That's pretty cool. Good to refocus sometimes. So this would be resonance, so that's not really affecting any of that stuff, although we should be seeing an effect from it. And then frequency, for some reason, just doesn't do anything. And it might be down to these transistors or these transistors. I mean, I don't know. But really, I should be seeing an effect from the filter at all. Nope, nope, killed it. There we go. The breadboard can be very frustrating in applications like this, where things will become just a little bit disconnected and it kills your whole circuit. The pot you were adjusting isn't connected to anything. No, 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 this is connected. So the pot I'm adjusting is freak. This freak right here is bias like 1 volt-ish to it's like what was it? It was like negative something to 3 volts. That's the wrong one. That's one that I shared. No. 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 Negative 11 to 3 volts, right? Negative 11 to 3 volts, and we're taking a third of that, and we're getting an output over here, and this is adjusting the frequency of the filter. Frequency of the filter is controlled by the reactance of diodes, which is to say a sensitivity to certain frequencies based on the amount of current that's going through it. So V equals IR and all that. So we have two loops here, and one loop is stealing current from the other. So when it does that, less current is allowed to flow through this whole system. Now, could it be down to the transistor differences between the ones that I used? Yeah, maybe. I don't think it's down to the amount of voltage drop, because that's the same. It could be that things are not matched. These may not be matched. These may not be matched. And that's sort of what I'm getting at, is I have a device coming in the mail that will be able to measure the transistors, and I'll be able to actually check them out and see what they do. I do also have a circuit board that does it, but I don't know if that's going to display properly on my scope. That's literally what we just did for the entire up to now, is we took a look at what those two transistors are doing in addition to what the op amp is doing. That's why I have all of these values written down, the -11 to 3, the -100 to 200. I just had my multimeter hooked up to it, where we saw the swing in minor voltages. Now, what kind of current? Oh, Jesus Christ! Hold on, I gotta change out glucose stuff so you guys get to see this view. I'm gonna put on this and mute myself. Sorry, I ran out of insulin. I didn't even eat lunch. What the heck? Where's Northern Exposure CD2? Oh my God. Northern Exposure. We'll do this one. Oh. Well, the problem being that I can't answer that question over and over if everybody's not been here the whole time. I'll be right back. I'm going to do a pump change. All right, this has been incredibly frustrating. Oh wait, hold on, I gotta plug back in. I was sitting on the mic cable. God, it's so frustrated. Okay. I am very frustrated right now. My circuits don't work. My mic doesn't work. At least my insulin stuff works. Did I move my fly up? Yeah, my fly's up. Okay. Jeez. What a process. All right. Let's get the music out of here. I didn't put a BRB on there. I need like a BRB insulin thing. But okay, my pancreas is back on my body. Running out of insulin in the middle of a stream is annoying. So what's going on? I don't know. I'm really kind of at a loss here for what is supposed to be happening in the circuit. I think this behavior might be down to unmatched transistors. I mean, to be honest though, if the transistors aren't matched, not much should be like if they have different voltage levels doing different stuff. Yeah, that's what yeah, exactly. It's odd that the pot changing its stuff, but the circuit isn't responding at all. That's what I'm looking at here. Like the BC337, let's take a look at the BC337. I don't think there's that much of a difference from like your generic 3904. I have the data sheet open around here. Yeah, there's 327. This is the one that I'm using as the diodes. I'm using it as the diodes because I just need a diode-like structure. It doesn't need to be matched or anything like that. So I'm using the PNPs because I don't use PNPs as much, right? So I'm using PNPs and I just put them in sort of the opposite way that they should, and they have the same properties as the NPNs. It's not, there's no difference there. It's just the same stuff. So that part should be fine. That part should be totally fine. The BC337, however, is what I'm using for my generic transistor. And if we compare it to 3904, I'd have read it. No. Two N3904 really does look almost like the same data sheet. They're both from onsemi, so they'll have the same specs in there. That's nice. So the 2N3904, 40 volt DC, 60 volt VDC, 45 and 50. 6 volt DC bias, 5 volt DC. We really should not be seeing all that much difference between the two. My only guess is that there's a misplaced wire. I mean, I can look closely at the circuit and take a look around and see what's going on and see if we can find another mistake, because I've corrected a couple mistakes and you know, they were legitimate, but I've been over this a bunch of times now, and I'm pretty sure I hooked it up right. But the 6 and 5 volts, I mean, it's like not that big of a deal, right? Unless we are specifically biasing it to 6 volts so that it's around the, but why would you be at the EB bias of the, maybe that is what that boils down to. What other transistors do I have in this pack that I've lost? Where did the pack go? There it is. Let's see if we can find one with an EB voltage of 6 instead of 5. But that's emitter base. Why would we be holding it at the emitter base voltage? I mean, look, like my study and understanding of transistors has fallen to the wayside, and this is sort of like a crash course at it all. So if you guys hear me say something exceedingly stupid, please correct me. I might not be receptive to it at first, but eventually I'll learn. If you are confident enough to come up against me. Okay, BC337. What about BC517? BC517. I have a transistor tester coming in the mail tomorrow. It was like $40. And then I'll be able to match pairs manually. This one's EB of 10. Next, 547. Watch this one be 4 volts. Bipolar junction BJT. I don't think that's NPN ecopolapicable. 6 volts for the 546 and 547. Okay, so let's replace all of them with BC 547s. This one's NPN, right? Yeah, NPN. So let's replace them with 547s. They're not going to be matched, but you think they're just putting the same chip with different markings on all these? I thought it was down to like you manufacture 1 billion of them and then you test the specs, and that's what puts it into the different part number bins. What features do you need from a transistor tester to do that? You need a transistor tester. LCR-T4 and most junk multimeters can measure transistor gain. I'm not sure whether it results in an authoritative match. I need a transistor tester. What are you talking about? I don't have one, so I bought one that tests transistors. It pulls it through the thing. I don't understand. I think you're making assumptions about what I bought. All right, so 547, or sorry, these are 337, 337, 337, and 337. And now I need to put 547s in their place. One, two, three, four, 5, 6. Let's see if that 1 volt made a huge difference. Oh, I have to remember how I hook these all up. Uh-oh. Uh-oh. Well, I know this one gets a leg stretched just a little bit, because it skips over this pin. So it goes here. Come on. No, wait a minute. Skips over this one. That's this one. So it goes here, here, and here. Oh, other way around. Oh, uh-oh. Already starting to mess up. So emitter, collect your bass. What's funny is that Sasha and Digweed album is what I would listen to when I would work on circuits like this during high school summers. Because I was a nerd. I wasn't out. We talked to this one. I worked at the mall at the time when I was listening to that album a lot. And talked to this one dude that was working at GameStop, because we were working at the bookstore at the mall, me and a friend of mine. And we talked to this one dude working at GameStop, and he's like, we're talking about like what games we're playing and stuff, and he's like, nah, I get home and it's women. It's like, so all I do is I call women and I talk to women. You're like, all right, buddy. $5 cheapo multimeters of transistor testers that'll tell you if it's NNP and then the HFE. That may have been what I got. I may have trouble figuring out if I can get a match, but it also has a signal generator in it, which is something that I could use other than this one that I have. I could use 2 signal generators. Where did these transistors go? Wait, did I even take them out? Did I take out the middle ones? Uh-oh. Well, I know I have the ones up here that I need to put in. That one. Do this one over here. Did you guys see me take them out of the bottom of the ladder circuit? Oh, let me get this one in. These 2 here, because that is all constructed properly. Yeah, I didn't take these out. Okay, so these come too. This one and this one. Spread these a little bit. It wasn't $5 though. That was more than $5. I think it does a little bit more than that. I guess I can check when I'm done streaming. I also do have a transistor tester that gives the full graph and everything, but that's for a tube scope, and I don't have the tube scope working yet. I do have enough equipment to make an equipment wall, though. I could really use an equipment wall. Why is this... Oh my god. Okay, then it suddenly accepts it. I hate it when the pin catches on something inside there. So we have... Let me just double check that I've got enough transistors on this board. In the... We're following the Hajiwo circuit because it's simpler. Oops. That would be kinks. Don't look at my kinks. That would be this window here. So we're looking at Hajiwo, which is in goddamn knows where is my window? I think it's in. I think I have the whole thing in paint, or do I only have some of it? No, I have the whole thing in paint. Yeah. So we have one transistor here instead of the 3 diodes, and then we have 1, 2, 3, and then another. So 1, 1, 2, 3, and then another. Okay. So we are in the proper configuration. And then instead of this structure up here, because I've got transistors, I have instead put this. So I've got the capacitor going to ground, I've got the 10 kilo ohm resistor, and then the bias of those two feed are fed from, yeah, the bias of that is fed from there, and then it goes down to the rest of the circuit. I don't have a 100 ohm resistor, I have a 1K, and I don't have a capacitor on this supply line, nor are the differential lines being fed from it. Is it possible that the Hajiwo circuit doesn't work? Well, I mean, on his YouTube channel, it seemed to work just fine. He's using the ladder of 3 diodes. I'm using a transistor, which should still be fine, because that ends up being like the Moog, the TB303 ladder filter. It's very much like this design. Only I have a capacitor on that. But that should work the same. Well, let's see if the transistor swap made any difference. Put in a whole new set of transistors. These I can test whenever my thingy gets in the mail. And then we are looking at ground. Let me move this ground over to here, so it's out of the way. We've got output over here. We don't need, well, yeah, we should probably just look, well, that'll come back on channel 2. We're looking at inverse out. Let's go. Oop. Whoa, that was a bit of a jump. Wait, where did my sweep go? Where'd my sweep go? What the heck? Okay, there, and then we just check this over here. Forrest, you wreck yourself! This BNC plug leaves a little to be desired. Whoa, we're shorting out. Where the hell are we shorting out? Where could we possibly short out? Did anybody get hot? Nothing got hot. It's like something before the setup is shorting, but these aren't shorting. They're not connected like that. Ground is up here. Oh no, that's plus 12 volts. Oh, so I shorted it through the scope. All right, let's turn this back on. Okay, now we're at 12 volts, and we got our sweep back. And do I see any frequency bias here? No, the 2 channels are in lockstep. Change the knob to one direction. They're still in lockstep. So that's amplitude. And this should be resonance, but I'm not really seeing any effective resonance. Why is that affecting the input signal? That's confusing. I am so lost. I mean, okay, so we need to check over the fundamentals here. We need to check over the fundamentals of the circuit and make sure that everything is happening the way it's supposed to happen. So I'm going to turn this off. We're going to do a check over because we're at that point where I got more functionality out of this than I did some of the other variants that I did, but I don't think anything is fundamentally wrong. From what I understand, the only thing that would be different is that I don't have super matched pair transistors. And it seems like you need 3 for the circuit. So until I get that thing in the mail that does the transistor testing, I can't match them. It's possible that I can't match them after I get the thing in the mail. I'm not sure. CyanoCat seems to be under the impression that I won't be able to do it. RF and analog is black magic. To a degree, it is, yes. But we're trying to demystify that a little bit. So let me get my pointing device here. And I don't mean to be rude to everybody out here, but I'm the one that's had my face in the circuit the whole time. People come and go with their suggestions, and it's funnier to be emotional on Twitch. I have to be emotional. This is something that I discussed with Uo at one point. You gotta let it fly. So I don't mean to be rude to any of you guys, but I also do mean to be rude to any of you guys. That's the nature of the beast. I must emote. I emote, therefore I have emotes. Okay, so the hookup. I got the hookup. Okay, so power lines are getting in the way. I'll just move them a little bit. So I labeled these in order to make my life easier. Listen, do the dumb guy stuff, right? Do the dumb girl stuff. Do the dumb whatever the fuck you want. Be dumb is what I'm trying to say, chat. You get here and you look at your circuit and you go, and you just be as dumb as possible, because that will help you eliminate confusion issues. If you want to be rude. No, I'm the one who's rude. You guys are not allowed to be rude. Because you guys are sitting at home and you don't gotta, you can reason with everything out and calm yourselves down. I'm not allowed to do that. I'm supposed to be angry. Plus 12 ground, then I did ground minus 12. And then I snapped 2 of my boards together. The reason I did this is because it's easy to consider the row that's facing towards the holes as ground. And then it's an order of potential, right? And then when you snap another board onto it, that's another one that's an order of potential. And the only shared resources in terms of power are right here. No other lines are crossing this. So if I want to unsnap this entire board, I can unsnap it, save for a couple little hookups, and move it around if I want to. So I cut these to length in order to make sure that they were correct. So I've got plus 12 volts here, and then it jumps down to the second board where it goes to plus 12. Same thing goes for minus 12. It jumps up and goes to here. Plus 12, of course, I had to do this little maneuver right here, but it works out. Ground goes to ground with just one jumper that I cut to length. I made sure about this time. I didn't want to have wires hanging over the side that can potentially get like brushed and moved. And a lot of the stuff with breadboarding is the more complicated your circuit is, the more you want to lock down all the structures and make sure that you don't necessarily have resistors that stick up like this or weird long connections. So you want to minimize the height of all of your stuff so that when you brush up against it in like a week when you've put this thing aside, you don't accidentally disconnect everything. So anyway, ground to ground here is the bridge between the 2 boards. It's the only one that's in blue. So that's all of our power hookups. So those are nice and fine. Now let's get the schematic up on the screen. Let's try to do that. And I could maybe, well, we'll just follow along. You guys can just follow along as we go through this. And I guess we'll do it from the website instead of from the, where did I put that window? Where did I put that window? That's not the window. I still have to fully get my file server up and running. Some of the shares are still messed up. Like this computer has trouble accessing file server stuff. Now I know that I saw the Hajuo circuit. There it is. Okay. So let's see if we can get a window of this up. So I'm going to add a Bauer source. This will be a, not doing display capture. We're going to do a window capture. I can tell exactly who's cooking upstairs by the number of times they slam the spoon on the side of the pot. Create new. Bower. There we go. So there's my Bower. And then I hit Alt to crop. It's on top of itself, so it's kind of confusing. I'll put that up over my face. Well, next to my face. We'll do that. We'll do one of these. Okay, cool. There we go. All right, so let's start from the input. Oh, wait, it doesn't need to be in this one. It needs to be in this one. So I'll add a source. Window capture, where's that? Power, that, there we go. Oh, I need to crop it again. Like, we don't really need thermals right now. I'll put it instead of thermals. Just sloppily. All right, so now we can see where we're following along. So, although I don't have the ability to paint over this, so I can't like circle circuit elements. Actually, you know what? I can't do that, and so we need to have the MS Paint up here, so I can circle things and show you guys what I'm doing. So I'm going to delete that. Delete. Where's delete? That's a minus button. There is no minus button anymore. Like remove, right? Remove. Properties, filters, blah, 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 blah. Blending, scale filtering, hide and mixer, order, transform, set, rename, remove. Oh, the delete key does that. All right, well, that's dangerous. Okay, so instead, I'm going to do MS Paint. And we are going to... Actually, do I already have an overlay that says paint? Scope, Streamlabs, Paint. Yeah, there we go. Wow, that is sloppy. Look at all that stuff that isn't represented. All right, so this is gone, and then this is gone. And then I bring this over here, and I expand it just a little bit. Yoink. Now I can zoom in, and we can see what I'm talking about. Okay, cool. So input. Actually, let's start with this. So this is the part of the circuit that adjusts how much... oh, wait, I can't get to the bottom of this window. There we go. The part of the circuit that adjusts how much current comes out of the whole thing. So this that's the wrong thing. God damn it. All right, all the browser windows go away. Come back here at MS Paint. This is Paint. Okay, so down here is where all of our current is being determined. How much current can flow down through this thing. And I mean current, not voltage, right? In this case, it is current and not voltage. So the current flows through this transistor right here. And that's this one right here, the BC337, or in this case, the BC547, which has very similar specs to the 2N3904, goes in the order of collector, emitter, or sorry, collector, CBE, collector, base, emitter, right? Collector, base, emitter, and I have it jumping over this pin because this is that 4.7K that goes up to positive 12. Positive 12, yumper, 4.7K to the collector of the second transistor. That's the one on the left. And that has the base hooked up to the op amp. This one has a base hooked up to ground. Ground. And that's this here. The little snoot that's coming off of this thing. I need two hands to operate Paint in the way that I want to. But that side of the op amp, by the way, is blanked out. That means shorting output and negative and then taking the input plus to ground. So anyway, over here, 4.7 to plus 12. This, check. Transistor, check. Output, the emitter to emitter right here. So that would be this part of the circuit right here, emitter to emitter. So there's a bridged over top. And by the way, if you're unfamiliar, these rows here are connected vertically, and then this here is connected horizontally. So we have the emitter to emitter that goes to a 4.7K. I can't center click to move this. I need to use the arrows, the scrolls. A 4.7K to negative 12 volts. So 4.7K, negative 12 volts. So far, so good. So far, everything we see on the screen is exactly what we have hooked up. Now, the base of this one, the one that goes to the op-amp circuit right here. This right here. That connection is this. So I have mercifully moved this all over, and I've sort of pushed the circuit out in order to spread out and be able to look at these structures and really get to know what's going on without having to kind of like, you know, piece apart all the space-saving mechanisms that I would use. So what I've done is jumped it over to a new spot, and now we're in the next part of the circuit. So the next part of the circuit has a 2.2K ohm resistor to ground. We check, we come all the way over here, G for ground. Okay. 2.2 to ground, and then 3 not 0.3, so orange versus red. Orange versus red on the color bands. If you are confused by color bands, I will never gatekeep that. I too am confused by color bands. Not so much confused as I am annoyed by them. Because boy howdy is it hard. Is the shirt gold or is it blue? I don't know. All I know is that they are in a blue background, which typically indicates that you are using 1% tolerance resistors. But then the actual color coordination of these things is ridiculous. Is it violet? Is that violet over there? I don't know. I hate these things. Surface mount resistors, so much nicer. So much nicer. Anyway, so over here we have what I assume is a 2.2K. Those look kind of right. Yeah, the paints these are terrible. And you know, everybody's lighting temperature is different. But on surface mount, they just write the value. On these, it's a color-coded band. So you've got Roy G. Biv, and that represents all of the numerical values and then the decade value at the end of it. And so you have extra bands here because your tolerance is so much tighter that you can have all of that extra information on there. Anyway, the point is 2.2 to ground. So that goes to ground. We know this is ground. We double-check that. What I'm doing right now, by the way, Chad, is I'm going through this piece by piece, and I'm just following the schematic through to its logical areas. I just go bit by bit, and I vet out each individual connection, and I make sure those connections are there, and I do this completely unpretentiously. I do not assume that I am smarter than I think I am, because I think I'm not as smart as I am do. But the point is that no ego. There's no ego at this point, because there will be a mistake in the circuit. And if there isn't, I'm going to be very annoyed with myself, because that means that something else fundamental is wrong with what I've built. Yeah, listen, I understand. Red is ground. Here's the point. I'm doing it in potentials. Plus 12 is over ground. Ground is over minus 12. And I've done it so that the inner track is ground. And then I also took from a McDonald's delivery, I took part of the delivery label and I put it on the ends of the breadboard so that I knew what I was doing. So this is, yeah, just tearing it down. I wish it wasn't red and blue. I wish it was like green or something, because then I wouldn't be held to the convention of color coding. Because we're in a plus-minus circuit, we're doing analog and it's synthesizer stuff, we've got plus and minus and ground. So this just makes the circuit so much cleaner. Inner track is ground, plus 12 on the outskirts, minus 12 on the outskirts. Yeah, it's technical upcycling. Greasy upcycling. So where are we? We are currently working our way to the op amp. So we haven't verified the value of the 2.2, and that's probably something that I should do. I'm not going to do it. So 33K right here. That's this one. Any color band nerds can figure that one out. And then we're jumping over the potentiometer, which is a little bit weird. I've got the potentiometer here. For display purposes, it could be over here. It just, I don't know, it's all relative. So 33 on the junction of the 2.2 to ground goes over to the output of the op amp and a 10K. I don't know why I'm getting hiccups all of a sudden. Hold on, I'm gonna take a big sip of water. Also, what's up, JBP? How you doing? That kind of came out JBP. Okay. Output of the op amp, 33K, into feedback resistor, 10K, into the second pin of the op amp. Now, power's coming from over here. This is the low input. This is the high input. Chat, remember what I said about no egos? Remember what I said about not having an ego and checking over your work? Mistake one, done. I was not feeding my op amp a full meal. In fact, it was sipping off of ground. Uh-oh. Uh-oh, spaghetti-o. Now, I'm feeding it 12 volts. Do you see? Do you see why we do this exercise? Do you see now? Do you understand why this stuff gets boring sometimes? Do you see why we do it? Do you understand? Do you see the mistakes? Josie. Okay. Interesting. So we were not giving our op amp a full meal. We can test it from here and see what happens. Keep going, there might be more. Shut up, I don't make mistakes. I'm gonna turn this thing on. Wait, where's our input signal? How come input signal is not coming in? 12 volt, 0.7 amp. Input's coming in here, output's coming from there. Push on this thing a little bit, tug it, spit on it a little bit. Maybe a little bit, just a little rub it. Maybe just rub it just right. You need to like wiggle it around a little bit. Kind of swish it in there, swish it out. Give it a little tap, a little tippy tap, maybe 2 little tippy taps. Maybe just spank it a little bit. Oh! Oh, ooh, that appears to be functioning like a filter. Ooh, I think it works. Yep. Although this does appear to just be controlling like the level of the whole thing. It should have frequency biases. Well, let's give it noise. Let's see what noise. Noise. Big up to the noise. Noise. So what I should be seeing here from an FFT, although the voltage levels are kind of pathetic. Why are you like this? From a math and from channel 1 is our output. Yes. Channel 1 is our output. Input is noise, output is this. Why did I have this hooked up this way? Because this one should be a monitor channel. Maybe I had it hooked up weird. Either way, if I do an FFT on this, channel 1, I don't know, I guess that's filtering. It's doing like a high pass. All those frequencies are getting through. It feels more like a volume control than anything else, though. It's not like super low frequencies are getting through still. What does it sound like? Cut off that feedback. I guess we were measuring the same thing. I wasn't looking at input versus output. I need to look at that. That sounds right. So there's a hiss. You're worried? I don't know if you guys probably can't hear that. If I put a wave through here, it'll be much more apparent. Hey, feedback, how you doing? What's going on there? Jeez. All right, back to square wave. Let's go back to the 2-volt square wave. Continuous wave, 50 hertz square, 0 volts. So amplitude, oh no, 50 hertz square, 4 volt blah blah blah. Why are we not? Frequency, 60 hertz. Oh yeah, I need to actually enable that. So yeah, turn off noise. Noise is coming from something else. Noise is coming from the circuit that we built to make noise. Noise. So that would be the supply. Which one is supply? That one is our feedback. So let's get the speaker off of that. Oh, no, I want the speaker. Crunchy. This is going through an attenuator that I have. And then here's the source. So there's not many frequencies that come through here. What's up, Noiseworks? Huh? What? Huh? Yeah, that doesn't appear to be working. Attenuation. And it feels like this is just simply cutting it off, but I think, will we see any difference over a sweep? Oh, I don't need FFT in there anymore. Get out of here. My BNCs aren't great, so there's weird stuff going on. I mean, we took it on a frequency sweep. I don't exactly have, I can't put an audio source through this at the moment. It feels like it does get softer with the ladder filter, but I don't know. Just make sure everything's pressed in here properly. I can't believe all my issues stem from. Watch what happens when I put a 10K in like we tried before. Let me turn this off and let me put a 10K on this thing and measure across it, and you'll all see. I'll show you. Where was, I think this might have been a 10K. Let's just measure that before I get any further. Probes? Over here. Hooking up the multimeter probes like this, having just DuPont connectors that connected to breadboard pins makes measuring stuff so much easier. Like if you're in doubt of what a value of something is, you can just throw it into this thing, and it's nice to have. So yeah, that one is a 10K. Bada bing. Although I could use possibly longer leads. Noiseworks. Do you know Gooseworks? One of these up-and-coming animators on YouTube. the whole works cinematic universe. So we take this from positive 12 into our circuit, just like the other side, just like the other side of the transistors. And now, assuming that I can actually do this, I can measure from here, and I guess if I hook it up to positive 12, that shorts it out. So I'm going to, oh, I know the reason why it shorts it out. It's because I'm plugged in to stuff. That's right. So if I wasn't plugged into anything like that, now we're isolated. Now my scope won't short out my input power. And you can see here by my holding the floating ground, you can see there's a huge 60 hertz noise coming into that because it is now isolated. So if I do between plus 12 and, just basically across this, I can do it the other way around though. Do it this way. Now I won't short out my scope, and I should get a good, yeah, there's 12 volts. And so this should be a pretty big spread. There it is. So channel 1, and if I recenter that, oh, why are we in fine? Oh, I clicked the wrong thing. I don't want fine, I want coarse. And I want it centered. There we go. Okay, so, you know, the math being what it is, if I go back and forth on this, you can see that swing in voltage levels, and it's readily apparent. Okay, so here a couple things that were wrong before. Okay, first, the op amp was not hooked up to positive 12 volts. Second, I had these BNC adapters, BNC to mono headphone adapters, hooked up over here, which grounded the scope to ground. It connects this ground to the scope, which means all of these pins are ground. So when I tried to measure it against positive 12 volts or negative 12 volts, I was shorting out my power supply, which would then back down the current and keep things from exploding. So those are the two big errors that we were having before. Now that I've realized the error of my ways, you can see, at least when things stabilize here, would you freaking stabilize already? That I have this wonderful voltage swing when I adjust this adjustment. So now this part of the circuit works. We know that it works. So now we need to check over resonance. So I'm going to turn this thing off. I'm going to get that 10K out of there. That was the whole beginning of the stream. That was the error. Those little things. Tweezers? Oh, there. Oh, I still had this hooked up to the rest of the circuit, so that's probably why it wasn't doing as good of a swing as it could have. I'll just sit it over here. So yeah, that feeds up into the diode ladder circuit. We have another piece of the circuit, and that's this right here. And that would be the resonance control. So we need to check over the resonance control and see what could possibly be going wrong with that. This is why we check things over. That's why we take a nice fat look at what we were doing and point out all the different structures in here. Okay, so I want to check over this part of the circuit. This part of the circuit is, zooming out, it's this right here. So that part of the circuit takes the output from the diode ladder and compares the two ends, the one where we're feeding resonance into it and the one where we are feeding just the base signal. And yeah, I don't know, those are just both feeding into that, into the comparator over here. So we have 6.8K biasing between these, and then we have 100K going in there, but we are 6.8 and 100, 6.8 and 100 on the feedback. And then we take a component of that feedback, isolated by 4.7, put it through a 50K potentiometer. It then, I guess, gets divided again. Maybe that's a bias or something like that. Oh no, maybe that's just to discharge the 10UF, so it doesn't hang out in there between the two caps. But we take it through another cap, and then we put it onto the transistor. This, I think, is keeping this part of the circuit from influencing the rest. This is a 10K, 10K voltage divider, so we, of course, have 6 volts running in this area because it's going from 12 volt to ground. So 6-ish, and then a 10UF is just kind of stabilizing that a little bit. And then over here, each of these are biased to the 6 volts by 2.2K. No idea. I don't know. I don't know exactly what that topology is supposed to be. But then if these are at 6 volt, this is pulling that through there. Oh, and the bias area of the transistors, or the BC or whatever. Hold on. From the data sheet, I think the collector emitter was whatever, 6 volts. Anyway, let's just check over parts of that circuit and just make sure that everything is functioning properly. Everything's hooked up properly, and I didn't mess up a power to ground kind of scenario. So we'll start up over here at the output. And so over here at the output, these little adapters, I forgot. I forgot to use female header instead of male header, and so they're extremely sloppy. But they do make good connection because those rounded pin female headers that I have don't go into the breadboard as far. But they're sloppy, but they work. I mean, that clearly that capacitor is making connections between those two pins. It just looks crazy. It looks kind of modern arty. Okay, so this is our output. This is our input. It goes to the attenuator first. Our output over here comes in through this third pin and goes through, and you guys can't see it. Why is that so far cut off? I can't get to that part of the drawing? Huh. Okay, so you can see here very clearly and very, very large and bold that there's a capacitor there on the input. So we are currently, damn it, we're here. So 1K, that would be this one making this big jump across. 1K goes to this first pin, and from the other op amp we worked on, we know this is the input. So this is power over here, positive 12 volts, hooked up correctly. Minus and output right here. And this is the positive input to ground. So we've stabilized that side. On this side, we have negative 12 volts. That's correct. Then on the positive lead, well, we got some BS. We're going to the output though. 1K to the output with a 100K feedback resistor. So that goes to the minus input. Then we have the two different sides of resonance, but also on the output right here is a 4.7 microfarad capacitor. Trust me, that was not easy to find. The 4.7, and that goes into one lead of the resonance adjustment. That is correct. There's nothing else hooked up to it. The center lead of resonance on this pin here has a 10K hooked up to it, and that's just a little bit further down. It's fine. The cap is fine. It works just fine. So there's the 10 UF. The 10 UF is one that I made to skip a pin, which is very convenient in this scenario because we can get it out of the center here. So there's a 10 UF right there, and then the other lead goes to ground. That goes to ground. 33K goes to ground, correct. And then this one goes up here. This one is the other side of the 10 UF. Up here and over to the base of a transistor, as well as a resistor that goes. Okay, so that goes to base of the transistor, and then a resistor that goes to a bunch of other stuff. So base of the resistor, 2.2K. Thing. Then that jumps over to here where it goes to the RC. And over here, the RC goes to positive. Plus, and then ground, not negative 10. That one also goes to ground, not negative 10. Let's look down here. Now, if I were to do this like really properly, we should probably like cross out all the stuff that we've checked over or highlighted or something like that. I'm not doing that right now, but it does help to do that because you can continue to follow along with what's going on. Let's go back to the op amp now. So we've traced that down. We go back to the op amp and we're looking at these big lines here. So one of the big lines, I mean, they each go to a 6.8K resistor, right? But they're on different sides of this feedback and cutoff thingy-majig. The ladder, different sides of the ladder, right? And they're symmetrical, but it's important to distinguish between the two. So one of the 6.8Ks goes to the same side that the resonance transistor's on. So the one that goes there is the positive one, and that has a resistor to ground. So we have resistor to ground, and then we have our positive op amp input, and that's on the same side as this one, which is the resonant transistor. We go all the way over here. Here's a red line. This is our 6.8, and then it goes to this line here, which is shared with the capacitor. and above that is the voltage source, which in this case, they took 3 diodes to whittle it down, but we have a different supplying schema. So that is correct. That is all hooked up correctly, which means down here with the blue line goes into minus, which is this top piece here. It has the 100 kilo ohm feedback resistor right here. And we trace it over to a 6.8K that connects to the source as well as the capacitor and this part of our PNP, which is the combined leads. That's over there. So that is all correct. So our input we checked. Did we check our input? We didn't check our input. Okay, so we've checked our voltage divider over here. We've checked this part over here. We have to look at this part. So on the 2.2K, going over to the other side of the circuit, here's our jump from the 2.2Ks. We're on the other side of the circuit. We got a 2.2 that's leading into the base, and then the base is also connected to a capacitor. That would be our 10K capacitor. And then over on the other side of the 10K, we have a 33K that goes to ground. That's this, just right here. It definitely goes to ground. And then we have our 10 kilo ohm resistor to the center tap of the potentiometer. One side goes to ground, which in this case, this pin here is ground. There's a jumper underneath. Double check that. There's a jumper. That goes to ground. And then our signal comes out the other side of the potentiometer and goes to our input. There it is. That's our check of the entire circuit. So now you guys know what's where, how everything functions. Everything looks just fine. But is our response exactly what it should be? Maybe not. My resonance adjustment doesn't seem to do anything. And I don't think that's down to like voltage biases and stuff. I don't think so anyway. Some kind of an error with the capacitors. I don't think so. And everything is hooked up properly. That would be this over here. I was really hoping we'd be sending like feedback wrong, or there'd be some misvalue on the op amp there, but it just doesn't look to be the case. I was really hoping I hadn't hooked it up to power right, just like the other one. Perhaps resonance is more dependent on matched components. I've seen ins and outs working just fine. There to there to there to there to there. Yeah, I don't know. I could go even further deeper and ohm it out and make sure that all my values are correct. But I don't think that's really strictly necessary. It's just for some reason we're not seeing the type of feedback that I think we normally would in this type of filter. All right, turn it back on. I've got a 60 hertz, 4 volt peak to peak wave going into it, square wave going into it. And I need to hook these back up. I don't know which one's output. There's output. Other way around? Yeah, other way around. Whoops. There's a square wave. And then we've got our probe pin here. Put that to ground. That's attenuation. This one's the filter frequency. Now, what would that look like inverse out? Let's take that up a little bit. And let's put the channels on top of one another. All right, so there's our wave. Let's get a better trigger. What are we triggering off of? Nothing, because I bumped the cable. Trigger menu. Channel 4. Go to channel 1. Channel 1 rising edge. There we go. All right, nice and stable. Lawn Dog, are you sure you did not damage the op amp? Or is the op amp working properly? That, you know, that, whoa. That might stand to reason. Let me wiggle it and see if it does anything differently. Oh my God. All the feedback that I'm injecting by wiggling this thing. Basically putting noise into the circuit. All right, let me take it through a sweep and see what's going on. Come on. Oh my God. The BNC is like really sensitive. It's not a good cable. There it is. So like the attenuation over frequency is not really changing all that much. If I turn up the frequency knob, right? Is that going to start? I guess it is. It is cutting out at higher frequencies. That is technically working. And that just cuts everything. This will allow more of the low frequency, and then you see it tapering off. All right, that's a result. So yeah, that is functioning. As we get to higher frequencies, we're going from 100 to like, I don't know, a couple kilohertz. And we do see that it is attenuating down the signal as we get to the higher frequencies. This is only over a square wave, but you know. Okay, so aside from that attenuation, so we go back to a continuous wave. And we attenuate this one. And it seems to just do that. So let's pop a new op amp in there. I got plenty of TLO-72s to spare. Is there one kicking around the desk right now? I might have put it away. Okay, let me get one out of the bin, which is somewhere over here. Hold on, I gotta go get it. Give me 1 sec. Give me 1 sec. I gotta get my bin full of chips. I'll never know what hit him. I don't suspect it's the op amp, but we'll try it. Try anything. TLO-72. Output is off. All right. So pop that sucker out. Get a new one in. All right. Let's try that. Sames. I don't know if this might be, again, I don't have matched transistors in here, and I have a device coming in the mail from Amazon that should settle that a little bit. I hope. Because yeah, this is a weird effect right here. That's not really what it should be doing. And other versions have other like different adjustments on it too. So I'm not sure. I've run into a wall. Welcome to the wall, everybody. This is the wall that we keep running into over and over and over and over again. I don't know how I would be able to test this part of the circuit externally either, because it's doing a differential of the two sides of the filter. Is my chat broken, or is no one chatted in 20 minutes? It is a quiet Tuesday. Tuesdays can get kind of quiet around here. Not to mention the fact that we're working on the same circuit again. Although I do have 60 people watching. That's like really nice. So I don't know. Chat, when am I going to pop off? When are all these advertisers going to be right? The ones that contact me and go, your channel is about to pop off and we want you to turn all of your financials over to us. Your account is high, which is why I'm confused. This is when somebody like, well, I shouldn't name names, but I know a particular streamer, and you guys could probably make 2 guesses and figure out who it is. But when chat starts to drop off, they start to talk like controversial, just dumb political opinions and stuff, and they don't even believe half of the stuff they say. They just say it in order to rile people up. I don't like doing that. I could do versions of that. I had a notebook where I had a bunch of like fun things to talk about. We're not ever going to get political on this channel. I hate politics. But whatever you think about my politics, you're probably wrong. Most people get the wrong impression from me. But you could probably guess where things lie, seeing as I'm dependent on insulin. But yeah, things get kind of dead. People put me on during work, and they'll go to like meetings and stuff. And so it's like, I'm here in the background fiddling with circuits. As long as it looks like somebody's doing work, you know, they'll count as a viewer, and I really appreciate that kind of stuff. You know, people like having, listening to my ramblings on while they work, and I can understand kind of the motivational factor. I am locked in on concentrating on what I'm doing because I have so many people watching me. So you have my duress from your watching feeding back into your ability to concentrate on stuff while working because I'm concentrating. It's a whole thing. I don't know. I genuinely do not know why. I had at one point resonance was working. It would create the little spike up and the little, you know, that little depreciating thing that would make like a cool noise. I don't think this is what it should be doing, which is turning it into like a sawtooth style wave. I don't think that's really what it's supposed to be doing. So I'm not sure where to go from here. Our frequency filter works now. Did you just slip in a little comment about being diabetic? Listen, man, I did a whole insulin change. I did a whole set change today. I did a whole set change. Like I'm being run by AAPS right now. I didn't eat lunch. Look at what that does for your glucose levels. I think I need to stop eating lunch again. I think I need to keep from eating lunch for a while because like this is amazing. I haven't eaten at all today, and my insulin pump is churning through insulin trying to keep my glucose level normal. But yeah, I am a type 1 diabetic. It's dependent on a lot of supplies that cost a lot of money. We can see that this thing is altering the frequency just fine, or rather it's doing the frequency cutoff just fine. We are very chill. We are very chill. We are not a pill. Okay, so I don't know where to go from here, to be honest. I am a 31-year diabetic, 31 years. And I've just gone over to pods, which are not cheap, and I burn through pods. My head is buried in soldering, so that's why I'm not super chatty. And listen, I would solder away, be prolific, do your solder thing. That's amazing that you're doing that. I'm happy for you. I wish I was soldering. Why can't I be soldering? It's so much easier. We're not there yet. Last week, I finally got to try the Humalog insulin and the Lantus. I'm desperately trying to figure it out. Yeah, I've been on Humalog and Humalin for 20 years, and they won't allow me to go to the more experimental, super duper fast acting ones, which would allow my feedback loop that I did to function a lot more tightly. I could actually like eat. One of these diabetics that's in chat, it's one of the ones in the Discord, is also on this Android Auto Pancreas system, and they've got the super designer awesome insulin, and so they're able to go to like Taco Bell and get a Baja Blast and just drink it and not do anything. They don't even think about it. What the hell? I am super duper insulin resistant because I'm a fatso, so it's kind of a PID. It's not exactly a PID. It does microbolusing, which your body responds to a little bit better, but yeah, I've been a diabetic for 31 years, so It's been a while, and I've been through several different types of management, and this one is the best for me because it means that I don't have to think about being diabetic as much, and I don't screw up. Like if I get like ADHD focused on something else, the pump is always going to be focused on getting my glucose level back to where it needs to be. So there's a couple. There's quite a few different insulins that are super rapid, fast acting. Oh, so you've been injecting the long and fast stuff. Listen, if that works for you, that's great. Yeah, the fancy stuff. I can tell you're from a different country because from here it's like $400 a bottle for the Humalog. It's horrible. It's horrifying. Waveform. I want to change the waveform. See what it does. So triangle. Whoa. Oh, yeah, stupid BNC cable. Resonance. Oh. 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 I wonder what that sounds like. Couldn't afford the $100 a bottle as far as being insulin resistant. Maybe that's what's going on because the Humalog doesn't seem to be effective as it should be compared to the type R for the same amount. Yeah, there's other formulations of Humalog that have been coming out, and especially in the advent of this $37 insulin. We didn't build this on stream. I built this on my own. Can't really tell. Let me up the frequency a little bit so we can hear it better. Frequency, feel like 100 hertz. Yeah, that's a nice woo. I mean, I guess it's doing something. I can't really tell. Be better if I had like actual music to go through this. And you guys probably can barely hear it in the background. It's probably not above the noise floor of my fan. Let's try different waveforms. I want to see what they look like, though. Let's not use the speakers. Turn those off. So what happened was last stream, we built most of this on a singular piece of perforated prototyping board. I ordered, these are the 3 new ones, because eventually the little clips inside of these things go bad. So we built the transistor ladder circuit on this, and I decided I still didn't have enough room at the end of that stream. So what I decided to do is spread out a little bit, and I built it across here. So this is the portion of frequency control coming from current controlling. What it basically does is has a current limiting resistor down here that goes to ground. So we have a current limiting resistor and 2 branches of the circuit that go through these 2 transistors. So as you activate one transistor versus the other, the current increases in one, decreases in the other. There's a fixed amount of current that's going through the overall circuit. And then you bias it with some resistors and stuff. So some current goes through here, through the one transistor down to ground. The rest of the current goes from here through this resistor and then down through the same resistor to ground. You have an equal amount of current between the two. So if you lessen the amount of current through this one, more current will then pass through your ladder circuit. The ladder circuit is designed to take advantage of the transconductance orchestra of a diode. And in this case, instead of diodes, I'm putting in transistors. They're PNP transistors that I've wired up in such a way that only one of the silicon junctions is in the circuit. The other one is just looped in. And what that allows us to do is, well, basically, it works like diodes. It works like a bunch of closely matched diodes, because I guess transistors are a little bit more closely matched than just regular old diodes. So as that current feeds through, certain frequencies are allowed to get through the rest of the circuit. And with them, with the circuit, with the input audio split up between 2 sides, one is a resonance feedback side, sort of, and the other one is the original signal offset. You can then feed it through the diodes and, I guess, have a differential. And the differential goes over to a op amp, a differential amplifier, where it is then scaled and output to the rest, to whatever else, to whatever's next. So the resonance is a feedback of that signal going against itself, and it creates all kinds of weird stuff going on here. You can see what it's doing to our Triangle wave. It does all kinds of strange stuff. And we've been over the circuit. We checked it over. Basically, the reason that I put this onto a new breadboard is so I could spread it out like this way so that we have modules. And then I also created the noise circuit from Kinks. So this is Mutable Instruments Kinks noise circuit. I participate with a few YouTube channels in electronics. If you'd like to possibly pick up some new people, try a channel called Learn Electronics. Wait, Learn Electronics Repair. These guys live on the Canary Island with the main show I watch as a guy named Richard on it. Neat. Do a lot of tinkering. It's worth a watch, not to mention some things you can learn. I do a lot of tinkering on my own as well. I'm not just limited to electronics, but I have a love for electronics. It's where I studied in school. It's what I do. The problem is I don't like watching a lot of other similar content, and I have a very good reason for that, and people generally agree with me, but I don't know why more people haven't talked about this, is that if I watch another channel's content and I really like it, I'll take on their mannerisms. I opened up AVE's channel and I watched that for a little while and I said, haha, keep your stick on the ice. Oh, he's so Canadian and macho, and this is kind of neat. He has a weird way of talking about everything that's kind of cute. And I was like, yeah, let's take on a couple of those mannerisms. That seems great. Like in the back of my head, I had no control over this. And so I go on his subreddit and I'm like, oh, neat, he has a subreddit. Cool, let's read some posts. They're all trying to talk like him. They're all trying to talk exactly like him. And it's like, ooh, no. And at that point I was like, yeah, I shouldn't be watching other content creators that do the same thing. Like full bridge rectifier, I will never say in a normal way ever again in my entire life. Full bridge rectifier is now what it is from now on. And I don't want too many of those because, I'm meme worthy. I can come up with something, assuming I get enough of an audience. If I get enough of an audience, then I'll have my own isms. You'll see. So yeah, that's sort of my philosophy behind this. I don't watch a whole ton of other content creators because I try to have my own unique swing on things. Techniques for making a channel enjoyable for others. Yeah. Don't take advice from me. It's okay. I understand, and I'm perfectly willing to talk about other channels and give them suggestions. I mean, that was more for the people watching than it was for anything else. It's like have other people watching some more content like this. If you want to find more stuff, that's where to go. So we didn't find any glaring errors. We didn't find an op amp that was dead. It appears, looking at a different wave type, we might have some semblance of attenuation going on here. And my unfamiliarity with that's the view I wanted. My unfamiliarity with the effect of this circuit on a fixed wave is coming into play here. Like this stuff, I don't know. I guess that's what's supposed to happen. I'd like to see you just earn a subscription for me. Who knows where to go in the future? Hey, thank you. I appreciate that very much. If you want to pay for a subscription, you can come over to Twitch. Twitch has paid subscriptions. It also has Amazon Prime free subscriptions that you can use on your favorite streamer, and you can slap that burger right out of Jeff Bezos's mouth. Triangles. So this was more. Oh, hey, come back. Saw that. There you go. This resembles the sawtooth that comes from the TB303. The TB303's particular flavor of sawtooth actually cuts off the peak a little bit. It makes a little flat spot on the peak. But what happens when we resonate with that? Whoa. It just doesn't feel to me like that's resonance. That doesn't feel like resonance to me. Maybe it is, but it just seems a little weird to me. Mystical rock hounding and fossils. Hunting for subs, checking for progress. Is it possible to look at one channel versus the other one to see if there's a difference in the way the circuit's working? See, the thing is, like, I tried to look through. You can do math functions on this, and so I tried to look at the differential using the math function of the scope, but it didn't really come up with much. Maybe we can try it now that we know it works. Let's try that. So I've got two probes, channel 1 and channel 3. I was thinking of the Wayne's World scene where he's going channel 1, channel 2. Channel 1, channel 2. So we'll go between channel 1 and channel 3 with ground as a reference, with ground as my witness. And those are offset by a voltage. Those are offset by a big voltage. So what I can do, turn off channel 2, turn on channel 3, and then go to math, and then I can math it up, and I can do one channel minus the other. So A minus B, channel 2, and I think I've already got it set up. Yeah, channel source A and source B, channel 2, channel 3. This is an Android-based Rigol scope. I am not sponsored by Rigol. I wish I was. Where the fuck? Negative 80 volts. This is a very useful place to be. Why are we at negative 80 volts? Go back to math function. Why would the keyboard work like this? Some little UI things need to be worked on. I don't think the math function is up to it. Let me get the, wait, why aren't the traces on screen? That should not be 30 volts. This thing is a maximum 24 volts. Keysight, look, there's no way. I sent an email to Tektronix and they ignored me. Rigol is cheap. I paid about $900 for the scope, which is cheap for a scope that can do what this thing does. Yeah, this thing also has the logic analyzer, and it's in dark mode, which I really, what influenced my decision more than anything else? Dark mode. But being that it is a modern Rigol, my non-modern Rigol had a lot of problems outputting. Their entry-level scope is going to do just about the same stuff, just at different frequencies. There's not a lot of, I mean, there is going to be a bit of difference between the two, but it'll be much less expensive for their entry-level scope. This is their DHO 914, so it's a slightly better than base-level scope. And the thing is, like, it also provides, and I think the base-level ones do this too, this screen you see right here is an intranet site. So it's just on my local network. It's 60 FPS. You can click on all this stuff with the mouse and change the values and stuff. So if you want to set up your scope remotely and it has an internet connection, whether it's to Wi-Fi or by the Ethernet line, you can hook that up and you can go walk back to your desk, open it up on your Bower window, and change the parameters of what you're looking at. For me, this is amazing because I get a 60 FPS readout on screen, and that means when we're doing stuff like this, or when we're reverse engineering like a digital signal and something periodic comes up, you need the full FPS so that you can see that blip. You go, wait, what was that blip? And you guys see what I'm seeing. That's a really cool thing about this scope. I had to replace the fan because in a studio environment I need no noise. So my audio is probably almost permanently wrecked for people who are on headphones because I have a big what do you call it? I have a big fan sitting on the floor behind me. That's all well and good for analog scopes, but this thing can also decode digital signals. So you find the digital signal, and then I don't need to switch scopes in order to get like a characterization or a decoding. Chat control scope. How would I do that? It's probably well and doable. We would have to just monitor network packets and then reproduce them. Long story of how I got to be the repair guy down at the Electronics on Board for product we had. $900 investment for somebody who's just a hobbyist. Yeah, the $400 and $500 version of the scope is really good, but you shouldn't lean into buying a scope unless you find yourself looking for signals at an almost constant, you know, like on a big level, I don't want to say professional, because having a scope as an amateur is perfectly fine. And you can look around used markets and find yourself a really nice, you know, like, what do you call it? Analog scope to do everything you need. I've got like, you can go down to the park and grab an oscilloscope. They're free. I have 5 oscilloscopes. No, the scopes are ridiculously expensive new. Used ones are fine. Things get out of tune. Like they have a certain amount of time when you have like a NIST standard tune on it. Sometimes places will just replace hardware. Other times they'll send it back to get tuned. But what, like, scopes are being sold as assets all the time. You could run on eBay and find stuff really nice and cheap. Or you can get cheaper scopes. There's a whole like ecosystem of cheapo sub $50, $60 scopes that do multiple different functions. And I've got one coming in the mail right now. And the extra crazy stuff that the scope does is measuring transistors. So the matched pairs that are supposed to be matched on this thing, possibly to influence resonance, could be found, I hope. Yeah, it's just the differential between these two channels, A minus B, it's not really doing it. What if I reverse A and B? Maybe one's a little bit lower than the other. Actually, I'll take it before the resistor, too. That'll bump up my signal level a little. Yeah, that just ain't doing. I'm just not getting anything out of that. Yeah. $250, yeah, $300. I spent $450 on the previous Rigel. I got the $900 one because I'm streaming now. And streaming has just a little bit more requirement of me doing studio stuff. Now, we haven't done any digital reverse engineering since I bought this. This is also my, what is it, quad-decade gift to myself. So it was a purchase from a milestone birthday, after which I have given up and I feel like I am now dust in the wind on the internet. But anyway, so I bought that for myself as like a big gift. And I'm not looking back. I don't regret the decision to spend $1,000 on this thing at all. It can do everything and then more. It can do things with a logic and an ease of use, like using a computer. And aside from a little bit of slowness, it takes over a minute to boot this thing up. And the loudness of the fan. Those are the two things that I would dock Rigel on. I don't know how they don't design these things with quieter fans, because oscilloscopes see all kinds of different environments, and having a noisy, and I don't mean electrically noisy, I mean audibly noisy fan there's kind of no excuse for that. All right, let's turn this off, turn channel 2 back on, and then get these off of here. So measuring it at the differential didn't work. That offset, I guess, is hard to deal with. For some reason, it doesn't A minus B itself away. And I don't know enough about my scope yet in order to get a differential signal out of it. That just made more mess on my desk. There you go. Triangle wave. What's going on there? Is that attenuation or frequency? Oh, for some reason it's just really, really weak. Why are you so weak? Hey, buck up. Come on. How is, okay, channel 1 is the probe, okay. Channel 1's the probe, so the probe is perfectly fine. It's this plug to the output that's super duper weak-tastic. That just gets rid of that. Oh, is this not plugged in fully? No, that's channel 1. Channel 1's plugged in fully. This one here, going to channel 2. Why are you so weak? That's attenuation. Did the probing mess something up? Could have. It could have. It might just have. Perhaps I've misjudged you. Huh, let me bounce power. Off. On. That's still pathetic. No, that's not this one's the problem. All right, let me rechat. Hold on. 100 megahertz scope with the signal generator. But then you can't observe your signal, can you? $250. Okay, that'll be pretty good. Yeah, tinkering and hobbyists, you might run into some issues here and there, but like we can get fully into RF with this thing and like high-speed signals. It's not generally where the hobbyist is going to end up. Like if I'm looking at Arduino circuits and stuff, this is really useful. But the lower tiers of scopes will also do that stuff just fine. Like if I'm messing with audio, I don't need an $800 oscilloscope. I can get a $200 one, and it'll do exactly what I need it to. It's just when I try to stretch that application to higher, you know, like if I have to check a a Salin key filter, I will be able to look at the output wave, but the square wave going into the Salin key filter, the PWM going into the Salin key filter in order to make that output wave might not be as measurable on the lower spec scope. But that's really the only place you're going to be working with that. And if you're doing high-speed digital circuits, if you're doing normal speed digital circuits, it should be okay. And then, you know, you buy the lower tier and you use it until it's dead. And then you go to yourself and you say, hey, self. And you're like, what? What do you want, self? And you're like, well, I think we need a better scope. No, you don't need a better scope. You need more crack. No, we don't need crack. We need a new scope. We need a better scope. So you save up. You know, it's the whole, who is that? I forget names. Crap. Anyway, his mantra is the same as mine. You buy the cheap tool, and when it breaks, you know that you're using it enough to get the expensive one. That's it. PC scope? Are those super cheap? No, they're not that cheap. That's what you're saying. Might be a bit better bandwidth for the same price as oscilloscope. I don't like involving the PC with stuff. I've been generally disappointed. I've been disappointed when I've done stuff like that. Why isn't my circuit working anymore? Hold on a second. Something weird is going on here. All right, so that's input. And then that comes over here. Just wiggle the stuff on the breadboard a little bit until everything comes back. So this is minimized as much as I can. Attenuation is at full. Frequency is at as high as it can go. Something is like leaking down the rest of our circuit here. And it happened when I hooked it up to the 6.8s over here. Did I break the op amp? That would be very strange. Op amps are usually a little bit stronger than that. So I'm just tapping on stuff. I'm just wiggling and tapping things on the breadboard. The problem with the breadboard and the resistors in particular that I used, as well as some of the other components, is that, you know, everything is being made super cheap these days, right? Everything is getting cheap. And in electronics, we already went through a whole cycle of them super duper duper cheapening everything. We've been there. We've been there for some time. It's just happening with literally everything else now. That's when people start to pay attention. But with electronics, we have been through that cycle. Everything is at the smallest possible margin of profit that it can possibly be at. The point is that the clips and the metal that's being used in these circuits, it's cheap. It doesn't necessarily spring back the way that it should. And it's thinner than it was before. So if you put a pin of a device into the metal clip, you can weaken the spring, especially if you put something like a potentiometer directly in, or even like a square pin header. It'll eventually wear it down over time. That's why I bought new ones of these for like 30 bucks. The other part about that is the pins on the resistor, the actual leads that come out of the axial resistor, are utterly and completely thin to the point where if you're soldering it, it's fine. But if you are plugging it into a perforated prototype and a solderless breadboard, those clips are not going to get that much pressure on it. Not to mention the fact that a bunch of this through-hole bullshit technology that I hate, I like surface mount. Surface mount is so much better. Anyway, this through-hole bullshit, you can knock up against it and change the connection. So what I've been doing as I've been talking to you guys and going over this circuit is just poking the bear. Just poke it, make sure it's standing up straight. Just give it a little wiggle here and there and just make sure that things are connecting properly. You can also see my ground loop going through some of these components, and as it influences it, you can see it wibble around with a little bit of wave. A little bit of wavy stuff. Yeah. Okay, let me read some of these comments because all of a sudden everybody started commenting again, which is nice. I worked in production with test automation for years. They shut down the plant, and I ended up with a ton of throwaway equipment. $100,000 new price. That's where I got my big servo motors from, because they have a certain amount of life to them, right? And after that, they're not necessarily broken. They're just not reliable for a factory. Where in a factory, if something breaks, you're out thousands of dollars. I don't really care if my steering wheel suddenly breaks, and I'm not putting it through 24/7 use. So it's a perfect relationship between hobbyist and industrial operation. Why is that getting warm? I guess that one just heats up. I have a 2K NI USB scope, but it's for automation. Oh, that sounds kind of cool though. I used to have a data acquisition card. It got stolen when I was at college in Philadelphia. Our house got broken into, and they stole the laptop that had this really nice, at the time, data acquisition card in it. It wasn't even mine. I was going to do some projects with it, but I never got around to it. Seeing a ton under $100 in Amazon USB scopes. Who knows if they're any good? I have a breadboard that has ground and power rails shorted. Oh my God, that's terrible. One where the 5-volt rail doesn't go all the way down. So the ones that really piss me off, the breadboards, and you don't see them as much anymore, but some of them have a split in the middle where half of them will be one rail and the other half will be another rail, and you have to put a jumper in the middle in order to tie them together. These are not that type. Married but living off one income, have for quite a long time, and things are starting to catch up with me. Oh, geez. Well, then you don't need to have those. Nobody needs a super expensive scope. You can get a cheap scope now because China's caught up with everybody. That'll give you just the same amount of data as this thing does. I don't care that this is super duper accurate to the volt. I mean, it does come in handy when I'm like tuning these circuits that I can get really accurate, I can get really accurate DVM measurements off of this thing. But that doesn't really matter that much. You can get a free app for the phone that'll tune things, I'll probably do a better job than me matching voltages. Connect a capacitor to amp lead and search for a signal. I mean, I guess. I don't know why my filter lost all of its chutzpah. I mean, it's just completely out of there's no girthiness to my signal anymore. What happened? And it happened when I plugged in the differential. So I wonder if I broke the op amp or something. Kind of been the way of breadboarding for the past 50 years. I have to be careful with the connection and understand sometimes. Yeah, I've had to go way more in depth in this circuit than I thought I ever would. Not as secure, should be making connections. You understand this stuff. Tell me your experience. Well, I've had a lot of frustration. We have this circuits book from 1974 that I've been using on Fridays. And every Friday, at least for a couple weeks there, we decided to build something out of the circuit book. And the circuit book is actually made up of 1974 and previous articles from electronics magazines. The problem is some of these neglect all the support stuff you need. They're like, oh, just put 60 volts in here. And we're like, wait a sec, huh? So it's been actually fairly difficult for us to go through these mostly purely analog circuitry and reproduce them on something like a breadboard. But hopefully, given a little bit more analog experience, which is what I'm trying to kind of clock here by doing this kind of stuff, we can uncover more circuits and do more cool stuff. Look at that, it didn't even respond to that. There we go, now it did. Why are we suddenly dead? Why are we dead in the water? 12 volts, let's look at negative 12 volts. So here's where I glance at the power supply. You take a glance at the power supply and you look at the amount of current that's going through. 0.7 is not that bad, and we're still at 12 volts, so the shunt protection hasn't kicked in. Minus 12 volts. 0.4, so that seems about right. And if I turn up and down the frequency knob all the way down, and then frequency knob all the way up, okay, that didn't affect it. In previous iterations, I had it actually affect that. Okay, so why did you fail me? Why have you failed me, circuit? I demand answers. I can keep poking stuff indefinitely. I may have damaged some of the transistors, to be honest. If you pull them out, they don't do anything. One way to test that could be the transistor test of the multimeter. I can take the multimeter to the transistors and see if they work. I can wait a day and have the transistor tester device come in the mail. I bought one of those multifunctional, silly little... $60. It wasn't a trivial amount of money, but I decided last night in the middle of the night, drunk, that I needed to have something like that. Oh, my shoulder's itchy. Oh my god, that feels great. Why is my shoulder so itchy? Okay, I don't think I knocked anything out here. What the heck? One of the things, now one of the reasons that I'm getting insight from this about Dave's particular synthesizer is that I'm seeing behaviors from this that I see in Dave's, like parts of the circuit just shutting down. If there's nothing pulling current through the filter, you get a flat line. You get sprung. Nope, it's not that. So you can see different modes of this thing and how things affect it. Like if, oops, wait a minute, that's plugged in wrong. So if I pull this transistor, flatline, which is kind of what Dave's is. Jesus Christ, what happened to these leads? Whoa there. Okay, look at that. There you go. And I broke the transistor. Yep. Okay, so I killed that transistor by just barely connecting it wrong. I put too many volts through the base. The leads are all effed up. You can see right here that they're all messed up. And so as I was trying to probe that back in and put it back in, I blew this up. So let's get another, and I'll put this over here. I'm going to put this in the pile with all the rest of the transistors because I have a transistor tester coming in the mail. So I can actually test the transistors and get them back where they belong and potentially find matched pairs. But we're doing BC547. I'm running out of. These things have that 6 volt, oh fuck, what specification was that? I forget. Let's just spread the leg out a little bit. And then that goes back. I'm gonna make sure I get the right pins. I don't short it out to anything because the circuit is currently live. 1, 2, 3. Ooh, that's a little janky, hold on. There we go. Established. Okay, so that didn't fix it. I mean, it did break it, but that also didn't fix it. You bought a cheap component tester, good and cheap. You know, it's what it's. I'll figure out how it does when I get it in the mail. If anything, maybe it'll be funny. That's sort of the philosophy. Why is my output level sucks? Why is this bad? What's going on? What am I doing? Is it me? Is it me? Do you not like me anymore? Am I the problem? Wait a minute, this thing is at 30 volts. That's what it is. It's a scope issue, PEBCAC. So this is my fault. Why is everything my fault, huh? Okay, yeah, 2 volt peak-to-peak signal. Channel 1 is on a different scale. No, channel 1's about the same scale. There. Channel 1 and then channel 2. There we go. So now they're on the same scale. I don't know why it's not able to get fully up there, though. The resonance thing? No, it's like a voltage limit thing. What's that all about? Yeah, good old PEBCAC. Is this your volt? 3, 2, 1. Channel 1 is on the same scale. What just happened? Oh, I bumped my input signal. Come on. Stop it. Stop doing that. Don't do that to me. Jeez. The cheap BNCs are the problem with this output. Why is it only 1 volt peak to peak on this? Let's look at this after the attenuator. Well, that was the wrong one, I guess. No, this is monitoring our input, and if I go here... Very strange. I don't know what's doing that. Is this cap being weird? That's after a resistor divider, so that's not going to do anything. A voltage divider. And then this is our pure input. It should be 2 volt peak to peak on the input because I've got 4 volts running through this thing. And then our output is coming from there. So for some reason, it's taking it down to 1 volt peak to peak. It should be 2. Maybe it's down to the feedback resistor over here being a little wonky. I just have the opposite issue. Works fine on breadboards. Solder the proto board and nothing works. Well, that's a skill issue. That's a skill issue. And you need to practice building stuff on the boards more. Because I had that problem for the longest time when I was a kid. And I kept at it. And eventually, when I was an adult, it took a little while. But when I was an adult, things started to go on. The perforated prototyping board, this stuff up here, it started to go together and work. 2 volt peak to peak. Yeah, the other one's going out of spec a little bit, isn't it? But that one's coming directly from the frequency generator. So my frequency generator is at 4 volt peak to peak, so +2, -2, which is the spec for the ins and outs of modular synthesizers, and it's what Acid Labs made their 303 do. So there are junctions between functionalities here that Acid Labs then took and scaled it to 2 volts and scaled it from 2 volts in order to make the rest of the synthesizer function. Things that Roland didn't have to do. Now, our circuit is based on a Hajiwo circuit. Hajiwo didn't necessarily follow a 2 volt pattern, but yeah, I'm just trying to keep it within those specs. So it might be that some of the amplifying stages and stuff are off by a little bit, but this looks different from what we found before. What we found before was everything was, you know, functioning great. And maybe it's just the sawtooth. Let's go to something other than ramp. So waveform. No, it's doing it for all of them. That's a weird mode. I don't like that mode. Ew, gross looking sine wave. It turns the sine almost into a square. I mean, that certainly is doing filtery stuff. Maybe it's also a function of the frequency that we're doing. We're giving it 100 hertz, so that might also be part of it. Here, let's see what it sounds like. Ooh. Oh, oh, oh. Oh yeah, that's lower frequency than I thought. It's actually, but it's very quiet. I can't really turn it up. Actually, I can. Never mind, I can't turn it up anymore. It's as loud as it gets. And all I hear is a very, very low hum. See if I can get this into position where you guys can hear it. It needs to go through my audio filters too, so that's another challenge. So that's kind of, it's rare. You guys may be able to hear that. That's attenuation, frequency. Cool. Okay. Well, this might actually work. This might be a working filter. It is like 60 hertz hum. It is actually 100 hertz hum. So, it's not that far off. What happens if we put noise through it again? I guess we already saw. Hey, Gonad, what's up? You missed a bunch of checking over our own work. Let me put noise through it. So cut that. And then we get noise, 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 noise. We put noise in here. Hiss! I guess that works. I don't know. I can't really hear. It just sounds like different kinds of hissing. 5 hours in a chair. Yeah, you're 5 hours ahead. It's like evening time for you. It's a nice early bedtime. All us geezers should be going to bed at around 10 o'clock. Why is it noise with a hum? What's going on there? Oh wait, I'm adding hissing to the input. So this would be the output that we're monitoring there. So we get hiss versus other hiss. Yeah, do you have a keyboard print on your cheek? Wave, slightly different wave. Let's pop up the frequency. The frequency is going to be a kilohertz. That's a whole lot of hertz. A kilohertz. It's having trouble keeping up with it until you lower the attenuation. You don't give it as much peaking towards the 2 volts. Turn down a little bit. Then the feedback. See, attenuation, I feel like it's not quite doing what it should be doing, but I guess it's doing stuff. Sorry, I mean the resonance. This one is frequency. Frequency is just going to look like amplitude because we're at a fixed frequency. We don't have more complicated of a waveform going through. I don't know. I'm willing to say that this is probably working. I would like to try to put actual audio through it. I don't have the hookups right now to do that. I would have to get my mixer back. What I'm trying to do is set up my old mixer on this table so that Julian and Dave can actually use it for audio stuff. And once I have that set up, I may then have the extra, bandwidth to do audio through there that we can hear. And then my other mixer is, of course, on the gaming computer. So hopefully there'll be 2 different devices on this computer. I think that's how that works. But yeah, I think we succeeded. And I think the main problem was just that this op amp right here was not connected to positive 12 volts. I think it wasn't able to assert the amount of amp control through this transistor in order to pull more current through itself than is pulled through the diode ladder filter, which, and don't ask me how because I have no fucking clue, but it has a property called transconductance where as you pull more current through the diodes in a millivolt scale, they will end up filtering out frequencies. Yeah, essentially, assertion is an important term in electronics. So we have a fixed resistor right here doing current limiting, right? So that's doing current limiting between 2 branches of a circuit. One branch comes from 12 volts, goes through a 4.7K through a transistor, and then through this part of the circuit. And that's controlled by this control right here, right? And so that's one branch. Whatever is left over, considering V equals IR and the whole loop equation thing, whatever current is left over is being sucked out of this thing's butt. So this thing is sucking its butt, and through this 1K to 12 volt, it is able to change the transconductance properties of these diodes in order to allow waveforms through. That's how our transistor ladder filter is working. And then on the outset, we measure the difference between the 2 signals, and we feed back a branch of that in order to create some kind of a cool little not attenuation, but a cool little like effect on the wave. It's a resonance effect on the wave. Now, matching pairs. Some of these transistors are supposed to be matching pairs. So once my tester gets in, I can test a bunch of these things and see what happens when I have matching pair transistors in here instead of just random ones that I found. And then, of course, finding the transistors that were exactly the spec that we were looking for. They matched the 2N3904 in one of the numbers anyway. They're all like the same thing. It's like there's really not that much difference between these sort of jelly bean transistors. But we are doing small signal effects on these things, so we kind of want them to have very, very similar specs, considering the rest of the circuit is tuned around a particular device. 2SC1815, I have a feeling we're going to see 6 volts BCE on. Let's just look that up real quick. I want to put that one to bed just to see if what I'm talking about is not theoretical and I'm actually as smart as my brain seems to assert. 2SC1815. 21815. The Central Semiconductor Series. Oh my God, just give me a data sheet. Data chart. He's reading the data chart. 6055. It's actually the ones we had in before were more matching of the V emitter base voltage. I don't know why we were looking at emitter base voltage, but that was one of the things that we were looking. Why is that window up? Get out of here. Did I miss any subs or anything? I think I got everybody. Only kind of sorta. I got Cosmo Questix, Celia Rusil, gifting to Leb TV 5 days ago. Yeah, not a lot of sub activity. When Burn the Subs gets back up, we'll work on that a little bit. But okay, so overall assessment of what we did today. Usually I don't do that, but I feel the need to because we've done a lot of streams with this stuff. It's been months that we've been working on this, right? And I hate to constantly be doing the same project, but I've needed to put this to bed and I've needed to learn more about how these circuits work. What is meant by matching pairs? Transistors have curves. Real transistors have curves. Real transistors are very curvy. If you take them through different voltages, you get different amounts of current through them. You look up the specs, there's a bunch of charts with multiple different lines on it, and those describe how a transistor allows current to go through itself. People use transistors as switching devices. That's when you bring it out to its extremes. Before it gets to the extreme where it allows everything through, it lets stuff through gradually. And so you can use that to amplify. You can use that to make filters. You can use that to do all kinds of cool stuff. So the curves in a super matched transistor pair match exactly. But since electronics are statistics, if you're building 10,000 transistors and you've grown a bunch of silicon in order to do that, you're not going to get the exact same transistors every time. There's going to be a tolerance level between them. And even still, yeah, there's just all kinds of dumb shit that happens. So you buy two from a supplier in China. One of them is a relabeled package that's something else. So you put them on a tester, you figure out what that curve looks like, and you match them up with each other. It's been done for centuries with electronics. And then they started to produce these expensive chips that were multiple transistors that are super matched. They figured out how to manufacture them to match exactly. And instead of manufacturing them all that way, they made it a special feature and charged you more. So yeah, withdraw 1,001, match 10, give 90 back. Exactly. We used to do that in the Drexel labs. You'd get like 16 resistors. Like, I need 40 10K resistors. You test them all. Here's 30 back. And they were all the leads were like all messed up from being in breadboards for too long. Anyway, yeah, super glue the matched ones together. I don't know if I've seen that before, but I have seen gluing the transistors, not just the can. You'd put a what is it, a thermistor on the can and then glue that together so that it was able to very accurately get the temperature of the transistors. But I don't think that's going to be strictly necessary for this filter. And I don't know if getting super matched transistors is going to do much for us. I don't think it's going to look too different. You know, we have this simulation here too. Clips to camera of self. We have the simulation here that we're all in. Where are we? We are looking at this Bower page. This is eddiebergman.com, which I feel like I'm familiar with. But Eddie Bergman made a synthesizer, and in part 39, they explored the Moog ladder filter and created this wonderful computer heating up diagram of all of the currents that are going through here. I'm going to bump up the speed a little bit here. The thing is, like, we don't get this response from ours. Not quite anyway. But you can see how the different currents are flowing through this thing and how it's being controlled. It's pretty cool. Pretty cool little simulation. The problem is all the fans on my computer start going crazy when I turn this thing on. Tempco, yeah, that was the name of it. I have one that has that whole setup and it doesn't work. But I get to repairing that one at some point. I need to redo all the wires on it. I took a larger synthesizer standard and I snapped it in half, and I took the two halves and I soldered wires between them in order to staple them together. And that was supposed to be one of my VCOs. I was hoping that it would create a lot of weird noise and stuff. And what it did is just render the whole thing useless and overly complicated. So I need to go back to that and fix it up and maybe use some motor wire on it instead of the big wire that I used. So, anywho, this is the Moog transistor ladder filter, and it is being shown with currents flowing, and it actually has a resistor ladder, unlike the one that's in the TB303, but it's similar, and it gives us an idea of kind of how this stuff is supposed to work. Current flowing down here, allows frequencies to come in. I don't know exactly what the dots are telling us. They don't, I think the color of the wire tells us the current, or does that tell us the voltage? And then the dot flow is the other one. I don't know which one is which. I need to learn how to read this in order to figure out what's going on, but it seems like a really cool tool. Okay, I'm done for the day. My brain has turned into mush. We managed to troubleshoot our filter. You know, I might bring audio into it and put audio through it and see what it sounds like. When I get that transistor testing tool, something that I've needed for quite some time, I can actually try to match a couple of these and get them in there matched and see if that makes any difference. I don't think it will. It might. Either way, this has given me an incredible amount of insight into Dave's synthesizer board. So when we come back on Thursday, either Julian and Dave will be here and they will be playing synthesizer stuff, or we will work on Dave's synth and they'll be here on Friday. I'm not sure which one they're going to opt to do. Julian laughed at me when I asked if he had any 4th of July plans. So that is to say, oh, I just totally crushed that. Sorry, I'm sorry. I'm so sorry. I'm sorry. Are you okay? You okay? I think he's okay. When the chips are down, when you don't know what you're doing, when things don't appear to be working in your favor for a long time, reproduce the circuit, build it up modularly so that you can test individual areas and understand how the math is working with the thing. And that gives you a huge insight into what can happen with these filters. I now know if I met, wait, did this just die? Did it just die? Did you die? You died. You died. Why did you die? Come back, please. Please. I can't. No. I think I just knocked. There it is. Please, you can't see without his glasses. Okay, so anyway, it'll give you an insight into how things should function. Breadboarding something is difficult in its own right. It is its own challenge. Spread out, work in pieces, vet out everything, and then hopefully in doing that, you will uncover some of the failure modes that you may be running into with the actual circuit. So hopefully that was useful for everybody. That's me. I'm done. Here's my end card. Y'all on YouTube are gonna just have to write this down. I'm gonna be back on Thursday. Wednesday is the time for stuff to get in the mail in case I have to order anything today. But here's the end card. I'll be on Discord. I'm always on Discord, and I will catch you guys on Wednesday. I'll be around the internet. I'm sure there's somebody who I could raid that I'm not gonna raid because I need to end and just get the dog outside for a walk because it's I'm overtime. So I gotta go walk a corgi. I gotta touch grass. I suggest you figure out a way to do the same, or just continue on with what you're doing. And I will see you guys on Thursday. Have a